Welcome. Get comfortable. Take a slow breath and let your body settle into wherever you are right now. There's nothing you need to do tonight. Nowhere you need to be. Just this voice and the sky above you and a question worth sitting with. What if the stars moved? Not drifting slowly over millennia the way they actually do, that almost imperceptible crawl across deep time that no human eye could ever catch, but really moved. Every single night. What if you stepped outside after dark and the sky you saw was completely different from the one you saw the night before? That's where we're going tonight. Into that sky. Into that question. So let yourself get heavy. Let your breathing slow down. And come with me to the first strange night. Imagine stepping outside just after dark. The sun has gone down. That last thin line of gold has faded from the horizon, and the sky above you is just beginning to fill with stars. You've done this before. You know this sky, or you think you do. But tonight, something is different. The stars are not where they're supposed to be. Every single night, the sky would look completely different from the night before. Stars appearing in entirely new locations across the heavens. Not shifted slightly. Not nudged a little to the left, completely rearranged, a whole new sky every time. Think about what that would feel like on that very first night. You'd look up and feel this low, quiet confusion at first, like walking into a room in your house and finding all the furniture moved. Your brain would search for the familiar anchors, the reference points it always uses, and it wouldn't find them. Not where it was expected anyway. And then maybe, slowly, the confusion would give way to something else. Something closer to wonder. Because the sky would still be beautiful. Extraordinarily beautiful. Just new. Now, we take for granted that the night sky is one of the most consistent things in our lives. Generations of human beings have looked up at the same stars in the same places. Your great-great-grandmother, on a clear night somewhere, saw exactly what you see. The same stars, the same rough positions. There's something quietly profound about that. So imagine what it would mean if simply looking up at the night sky became a daily surprise. Each evening would reveal a celestial scene nobody had ever seen before. Nobody. Not your parents, not the greatest astronomers who ever lived. Not anyone. Every night sky in this version of the universe would be a genuine first. A one-of-a-kind arrangement of light that had never existed and would never exist again. You might start going outside earlier, just to catch it while it's still fresh. You might call someone over. You might say quietly, "Come look at this," because you'd know that by tomorrow night it would be gone. There's something a little bittersweet about that, isn't there? Something that feels almost familiar. The way a sunset works. The way a good day works. Here and then not. Unrepeatable. The sky in this world would understand impermanence in a way ours never quite does. Let your eyes feel heavy. There's no rush. We have all night, and the sky has much more to show us. Let's talk about the constellations. The constellations are, in a sense, a human invention. The stars that make up Orion, that great hunter standing in the winter sky, are not actually near each other in space. Some of them are hundreds of light years closer to us than others. We just happen to live at the angle where they line up into that familiar shape from our vantage point. An accident of perspective turned into a story. But in our sky, that accident has held steady for so long that the stories feel permanent. Orion has been the hunter for thousands of years. Ursa Major, the Great Bear, has wheeled around the pole for longer than any civilization has been writing things down. Cassiopeia, the queen in her chair, has been sitting there since before anyone thought to name her. In a sky where the stars moved every night, all of that would be gone. Familiar constellations like Orion, Ursa Major, and Cassiopeia would constantly break apart and reform into new patterns. Every night, the hunter would scatter. The bear would dissolve into a loose scattering of unrelated lights. The queen would step off her throne and vanish into the dark. And in their place, new shapes, new accidental alignments that nobody had named yet, because nobody had ever seen them before. Some nights, the stars that happen to end up close together in the sky might form a shape that looks like something. An animal, a face, a hand reaching out. And you would see it, and you would name it in your own mind. And by morning it would be gone, unmade, scattered back into the dark to become something else somewhere else the following night. Every culture on Earth builds stories around the night sky. The shapes we see up there say something about who we are, what we fear, what we love, what we hope for. In this world, every single person, every single night might see something different, might tell a different story. The sky would become the most personal thing in the world, because no two people watching from different places would see quite the same arrangement, and no night's arrangement would ever come back. The constellations would become something more like dreams, vivid and real while they lasted, and gone by morning. Breathe slowly. Let your thoughts soften a little. You don't have to hold on to anything tonight. Now here's something worth sitting with. Some nights in the sky would be more extraordinary than others. Some stars could occasionally appear much closer together in the sky, creating temporary groupings. Not just vague constellations, but genuinely tight clusters of stars, close enough together that even without a telescope you'd notice them. Little knots of light, gathered and bright, hanging in the dark like something that meant to be there. And some nights, those clusters would be spectacular. Some stars might appear to gather into temporary formations, creating breathtaking celestial displays visible to the naked eye. Think about what that means. Not photographs, not telescope images that only astronomers get to see. Just you standing in your garden or on your porch or in a field somewhere, looking up at a sky that has decided, tonight, to put on a show. A tightening of stars in the north, a gathering brightness, something that wasn't there last night and won't be there tomorrow. Word would spread, wouldn't it? You'd call your neighbor. You'd post about it. You'd drive somewhere dark to get a better look. It would be the kind of thing people traveled for. The kind of thing that could stop a whole city on a clear night. And then it would be gone. On some nights, unusually bright stars could gather in one region of the sky, creating temporary celestial superconstellations visible from across the entire Earth. That word is worth staying with for a moment. Visible from across the Earth. Right now, the sky looks different depending on where you are. Someone in the northern hemisphere and someone in the southern hemisphere don't see the same stars. But something brilliant enough, concentrated enough, gathering the brightest lights in the sky into one region, one spectacular blazing corner of the heavens. That could be something else entirely. Something that crossed the boundary. Something everyone could see wherever they were. Imagine what that would do to a world. A sky event so bright and so extraordinary that people on opposite sides of the planet, looking up at different angles, could all see the same blazing concentration of light. Not an eclipse, not a comet, just the stars, rearranged into something almost incomprehensible. People would have watched for it in that world. They hoped for it. Gone to sleep wondering if tonight might be one of those nights. There would be a whole vocabulary built around it, eventually. Ways of describing the brightness, the shape, how long it lasted, how it compared to the last great gathering 3 weeks ago. The sky would be something you followed. Something with seasons and patterns, even if every individual night was a surprise. Let your body sink a little deeper. Your shoulders can let go. Your jaw too if you're holding it. The brightness of the night sky could vary dramatically from night to night, depending on where the nearest and most luminous stars happen to appear. We don't think much about this, but our night sky has a certain characteristic brightness. On a clear night with no moon, far from city lights, it looks a particular way. You can read by a full moon, but not by the stars alone. The stars give a cool, dim, silver blue kind of dark. In a sky that rearranges itself nightly, that baseline would become unpredictable. Some nights, Earth might find itself facing unusually dense concentrations of stars, making the sky appear far brighter than it does today. Just think about that for a moment. A night sky brighter than anything we have ever seen, not because of the moon, not because of light pollution, but because the stars themselves happen to cluster in our direction. A natural brightness, ancient and vast and completely indifferent to the fact that we were watching. Animals would be confused by it. Birds that navigate by the stars would have to find another way, or perhaps adapt over time. Plants that time their processes by darkness might respond differently. And people, just people trying to sleep on a too bright night, would lie awake with light seeping around curtains that weren't designed for a sky like this. And on other nights, the opposite. The stars would thin out, face the other direction, and the dark would be darker than you had ever known it. A genuine, complete, almost velvety dark, with only a handful of lonely stars scattered across the vast depth of it. The kind of dark that makes you feel small, but quietly, without fear. The kind that makes the universe feel very large and you feel very briefly part of it. We're nearly at the end of our first stretch of sky, but there's one more thing worth considering. The overall appearance of the Milky Way band could change dramatically from one night to the next as stars shift throughout the galaxy. On a clear night away from the city, you can sometimes see the Milky Way, that pale, irregular band of light stretching across the sky, our home galaxy seen from the inside. It looks like a smear of cloud that doesn't quite move, denser in some places, thinner in others, faintly luminous and enormously far away. In a sky that rearranged itself nightly, even that would shift. The band itself would change shape, change brightness, change where it arced across the sky. Some nights it might be almost absent, thin and faint and hardly worth noticing. Other nights it might blaze, thick and bright and full of more visible stars than you could begin to count. Your galaxy seen fresh, every night. And so the night sky in this world would become something unlike anything we know. Not the fixed, reliable backdrop that human beings have stared up at since before we had words for any of it. Something restless, alive almost, more like weather than astronomy, more like the sea than like a map. The night sky would become one of the most dynamic natural phenomena on Earth, a constantly changing display that no one could predict, no one could fully document, and no one could ever truly learn by heart. And maybe that wouldn't be a loss. Maybe it would just be a different kind of gift. Not the comfort of the familiar, but the quiet electricity of never knowing what you were going to find when you looked up. The sky keeps shifting, keeps rearranging itself in the dark above you. And as it does, let's follow a thought that begins not with wonder, but with a quieter kind of consequence. Because a sky that changes every night is not only beautiful, it is also, in a very practical sense, useless. At least useless in all the ways that human beings, for thousands of years, desperately needed it not to be. Come with me for a while into history, into the long, slow story of how people learned to live on this earth, and how much of that story was written by looking up. There is something easy to forget when you live in a world of GPS and smartphones and satellites quietly circling overhead. Something that gets lost when every road you've ever driven has a little blue line on a screen telling you exactly where to turn. For most of human history, finding your way was one of the hardest and most important things a person could do. Not just explorers, not just sailors, ordinary people, merchants moving goods across continents, armies, pilgrims, nomadic communities follow herds across open land, people carrying messages, carrying seeds, carrying the things that held communities together across vast distances. And for all of them, for thousands upon thousands of years, the night sky was the most reliable map they had. Ancient cultures built knowledge of that sky over generations. Patient, careful, accumulated knowledge. Watching which stars appeared at which time of year. Noting where they rose, where they set, which direction they pointed. Passing that knowledge down through families, through traditions, through stories and songs and markings carved into stone. In a sky that rearranged itself every single night, none of that would have been possible. Ancient cultures would never have been able to create the star maps that guided travelers for thousands of years. All of that accumulated wisdom, those generations of careful watching and recording and teaching, would simply have had nothing to work with. You cannot map what will not stay still. You cannot teach the next generation to follow a star that won't be in the same place twice. The great star catalogs of ancient Babylon, the celestial charts of China, the navigational knowledge of the Polynesian peoples, the astronomical records of Egypt, all of it built on one quiet assumption so obvious nobody ever thought to state it, that the stars would be there tomorrow in the same place they were today. In our imagined sky, that assumption would never exist, could never exist. And so those traditions, those deep and patient bodies of knowledge, would simply never be born. Let your breathing be easy. There's nothing to figure out tonight. Just listen. Navigation by the stars would become almost impossible because no celestial landmarks would remain fixed. The word landmark is interesting when you apply it to the sky. A landmark on land is something that stays put. A mountain, a river bend, a distinctive tree on a ridge. It marks a place, and it marks it reliably night after night, year after year. The stars in our world are landmarks in exactly that sense. They stay put. Not perfectly, not forever, but on any human timescale, on the timescale of a single life or even a civilization, they are fixed. You can rely on them. Take that away and you take away something fundamental. Not just a tool. A whole way of orienting yourself in the world. Sailors crossing oceans before the invention of modern instruments would have struggled terribly to determine their direction at night. And this matters more than it might sound, because for much of human history, sailing was one of the most consequential things people did. It opened trade routes, connected continents. It was how ideas and goods and people moved across the world. A sailor in the open ocean, out of sight of land, at night with no instruments and no fixed stars, would have been in a very dangerous situation. Not just lost in the practical sense, lost in the deeper sense. Without any way to know which direction was home. They would have managed, of course. People are endlessly resourceful. Ocean currents, the behavior of birds and fish, the direction of swells, the color of the water, the way clouds form over distant land. All of these things carry information, and skilled sailors learn to read them. But the sky on a clear night is the most legible thing in the natural world. Or it is in our sky. Simple, clear, unambiguous. In a sky that rearranged itself nightly, the most legible thing would become the most confusing thing. And the history of human exploration would have been slower, more cautious, shaped by that absence in ways that would be very hard to trace. There is one star in our night sky that deserves a moment of its own here. Polaris, the North Star. It sits almost directly above the North Pole of the Earth. And because of that, as the Earth rotates, as all the other stars sweep across the sky in their long nightly arcs, Polaris barely moves. It just sits there steady in its place. A fixed point, a pivot around which the whole sky turns. For navigators across enormous spans of human history, in cultures spread across the entire northern hemisphere, this single star was invaluable. You didn't need instruments, you didn't need charts. You just needed to find Polaris. And there it was, telling you where north was, telling you where you were. In our imagined sky, the North Star would no longer serve as a reliable indicator of north, because it wouldn't be the North Star anymore. It would just be a star, somewhere up there, in a different position than it was yesterday, holding no particular relationship to anything you needed to know. And that loss, that single loss, would echo through centuries of history. Armies that moved at night, refugees following paths toward safety, caravans in the desert, fishermen trying to find their way back to shore before dawn. All of them were deprived of something that, in our world, they could count on completely. The North Star is so reliable that it barely registers as remarkable anymore. It's just there. We take it for granted the way we take for granted so many things that are quietly, consistently, enormously useful. In a world where it moves, you might understand its value more clearly. The way you sometimes understand the value of something most deeply after it's gone. Your eyes are heavy. Your body is settled and still. The night is long and quiet, and there's no need to rush through any of this. Let's move from the sea to the desert. Human explorers crossed deserts at night, and many did, not to avoid the heat, though that was part of it, but because the desert at night is navigable in a way the desert by day is not. Those explorers would have had to depend far more heavily on other methods. Landmarks where they existed. Compasses, once those were available. The direction of the wind. The lay of the dunes. But in our world, for those crossing the great deserts long before the compass arrived in their part of the world, the stars were the compass. The sky was the map. Remove that and the desert becomes a much more featureless, much more dangerous place. There's something very human about this. The way we have always reached for the biggest, most distant things to orient ourselves within the smallest, most immediate problems. I am here, in this sand, in this dark, and I don't know which way to walk. So I look up at something 1,000 light years away, and somehow, improbably, it helps. That relationship between the infinite and the immediate, between the cosmic and the personal, is something that a shifting sky would have quietly severed. Not dramatically, not all at once, but steadily, over time, the sky would have become a ceiling rather than a compass. Something above you, beautiful perhaps, but not something you could use. Breathe slowly. Let your thoughts drift where they want to. Now here is something that might surprise you. Something that connects the stars not to travel but to time. Calendars based on seasonal star positions would be unreliable in this shifting sky, forcing civilizations to depend more heavily on the sun and moon to track the passing year. We think of calendars as a fairly modern, fairly administrative kind of thing. A grid on a wall, a number on a phone. But the need to track time, to know where you are in the year, is ancient. And for many ancient civilizations, the way they tracked time was by watching which stars were visible. In the northern hemisphere, different stars are visible at different times of year as the Earth moves around the sun. The rising of certain stars at certain times signaled the coming of certain seasons. It was a clock written across the whole sky, readable by anyone who took the time to learn it. Farmers who historically used the appearance of particular stars to mark planting or harvesting seasons would need other methods to track the year. And this is not a small thing. Getting the planting season wrong, getting it even a few weeks wrong, could mean the difference between a crop and a famine. Time for a farming community is not abstract. It is the difference between eating and not eating, between a village surviving winter and not surviving it. Those communities would have found other ways. They always did. The sun follows a reliable path. The lengthening and shortening of days is trackable without instruments. The moon's cycles are consistent. There is enough to work with. But the richness of the sky as a calendar, the way different civilizations wove their whole understanding of the year into the stars, all of that would be absent. The year would be a simpler thing, a less storied thing, measured in shadows and moons rather than in the rising of Orion or the return of the Pleiades. And here is something even more interesting, something that reaches beyond navigation and farming into something harder to define. Indigenous knowledge systems that incorporate stable star patterns for navigation and seasonal planning would develop in very different ways in a world where the stars move nightly. There are cultures on this earth whose relationship with the night sky goes deeper than maps and calendars. Cultures where the stars are not tools but relatives. Where the sky is not overhead but all around. Where the movements and appearances of stars are woven into stories about identity, about belonging, about how the world came to be and what it means to live in it. The Aboriginal peoples of Australia, for instance, have one of the oldest and most sophisticated astronomical traditions on Earth. They read the sky in ways that European science took centuries to catch up with. They navigated by it, timed ceremonies by it, embedded it into a worldview that connected the land and the sky and the human community into a single coherent whole. That tradition, like all traditions, was built on one thing: reliability. The sky was reliable. The same patterns returned. They could be learned, trusted, built upon. Take that away and you don't just lose a tool. You change the shape of an entire way of understanding the world. The stories would be different. The ceremonies would be different. The relationship between people and the sky would be different, perhaps more cautious, perhaps more mystified, perhaps more focused on what changed rather than what stayed. It is impossible to say exactly what those traditions would look like, but they would look different. The sky for those cultures was not just above them. It was part of them. And a sky that refused to stay still would have required a whole different way of being in relationship with it. The night is deep and you are somewhere safe and warm. Let your body be heavy. Let your mind be soft. Whether folklore connected to the appearance of specific constellations would likely never emerge in this shifting sky, since those constellations would not remain consistent enough to attach meaning to. This is a small thing, perhaps, compared to navigation and calendars and indigenous knowledge systems, but it is charming in its own way and worth a moment. People have always tried to read the sky for signs about what the weather would do. Some of those readings are genuinely useful, based on real physical relationships between atmospheric conditions and the behavior of light and clouds. Some are pure folklore, patterns noticed and passed down without much basis in reality, but with a great deal of warmth and personality. Red sky at night, sailor's delight. When a halo forms around the moon, rain is on the way. The Pleiades setting at dusk means winter is coming. That last one connects the weather to the stars directly. And there are many like it across many cultures, linking the appearance of particular star groups at particular times of year to the expected behavior of the seasons. In a world where those star groups never appear in the same place twice, none of those connections could be made. None of those sayings would ever be spoken. None of those pieces of folk wisdom, imperfect and partial and human as they are, would ever be born. The world would be slightly less full of that particular kind of knowledge. The kind that isn't exactly science and isn't exactly superstition but is something in between. Earned by long attention. Passed down by people who cared about the sky and wanted it to tell them something useful. And finally, one last thought before we move on. A quieter, more academic kind of loss, but a loss nonetheless. Historians studying ancient records of the sky, in a world with a shifting sky, would find very little consistency between observations made on consecutive nights. In our world, historical astronomical records are extraordinarily valuable. Ancient records from Babylon, from China, from medieval Europe, describe the positions of stars and planets with enough precision that modern astronomers can use them to trace the movements of celestial bodies across thousands of years. They are a time machine of sorts, a record of the sky as it was verifiable against the sky as it is. In a world where the stars moved every night, those records would tell a very different story. They would be full of contradictions. A star recorded in one position on one night appears somewhere completely different the following night. A constellation described by one observer having almost nothing in common with the same constellation described by someone watching a week later. Future scholars trying to make sense of those records would find themselves looking at what appeared to be chaos. They might doubt the accuracy of the observers. They might think the instruments were faulty, the scribes careless. They would not know, looking back, whether the inconsistency was in the watching or in the sky itself. And that is a particular kind of loneliness, isn't it? Not being able to trust your own records. Not being able to look back and find a thread of consistency running through all those careful observations made by all those careful people across all those careful years. Our sky gives us that thread, quietly, reliably, without ever asking for acknowledgement. The stars that were there last night will be there tomorrow night, and the night after that, and 1,000 nights from now. And because of that, we can look back across millennia and find the same sky waiting for us in the old records. A fixed sky is a kind of memory, a way of holding time still for just long enough to understand it. And on a night like tonight, when the questions are bigger than the answers, that is not nothing. That is, in its own quiet way, everything. We've talked about maps and calendars, about sailors and farmers and the practical business of finding your way through a world without fixed stars overhead. And all of that is real, all of that matters. But now let's move somewhere softer, somewhere closer to the heart of what it means to be human. Because human beings have never just used the night sky. They have felt it. I wondered about it, been frightened by it and comforted by it and moved by it in ways that have nothing to do with navigation or agriculture or the tracking of time. We tell stories about the sky. We always have. And in a sky that moved every night, those stories would be very, very different. Start with the simplest question, the most ancient question, the one that every person who has ever stood beneath a clear night sky has asked, in some form or another. What are those? In our world, we have answers. Distant suns, most of them. Some close, some incomprehensibly far. Burning hydrogen, producing light, held together by their own gravity. The physics is well understood, even if the scale of it still staggers the imagination. But those answers took a very long time to arrive. For most of human history, nobody knew what the stars were. They were just there, bright, distant, silent, and fixed. And that fixedness, that permanence, that sense of something that was there before you were born and would be there after you died, that shaped the answers people gave. The stars felt ancient and settled because they were ancient and settled. They felt like the backdrop against which human life played out. Reliable, indifferent, eternal. In a sky where the stars moved every night, people throughout history might have viewed them very differently. Not as distant suns, not as fixed and ancient lights, but as mysterious living objects. Things with will and intention. Things that wandered because they chose to wander. Think about what that would do to the human imagination. A star that moves is a star that is going somewhere. And something that is going somewhere has a destination. And something with a destination has a reason. The stars in that world would feel purposeful. They would feel alive in a way that our stars, for all their grandeur, do not quite feel. They would be less like backdrops and more like characters, less like scenery and more like neighbors, unpredictable, wandering, occasionally brilliant, occasionally dim, moving through the sky on errands you couldn't quite fathom. The night sky would feel inhabited in a way ours never quite does. And the stories people told about it would carry that sense of life, that sense of intention, through every culture and every generation. Let your body settle. Your arms heavy, your legs heavy, your thoughts moving slowly like clouds on a still night. Many myths and legends based on constellations might never have existed in a sky like this, because the shapes that inspired them would constantly change. The great constellation myths are some of the oldest stories we have. Orion the hunter, placed in the sky by the gods after his death. Cassiopeia, the vain queen, condemned to circle the pole forever. The great bear, the scorpion, the twins, the maiden. Story after story after story, each one attached to a particular shape, a particular arrangement of stars that stays put long enough to be pointed at, named, taught to children, woven into the fabric of a culture. Those shapes are what makes the stories stick. You tell a child the story of Orion and then you take them outside and show them the 3 stars of his belt, and suddenly the story has a location, a home, a permanence. It's up there. You can find it. It's always been there and it always will be. In a sky that rearranged itself nightly, that anchoring would be impossible. You couldn't point at Orion because Orion wouldn't exist. The 3 stars that make his belt would be scattered across completely different parts of the sky, mixed up with stars they'd never been near before, and by the time you told the story, the stars you were pointing at would be different ones anyway. The great constellation myths, the ones that have survived for thousands of years, passed from culture to culture across the ancient world, those specific myths would never be born. The stories humanity tells about itself through the shapes in the sky would be completely different. Or perhaps there would be no sky stories at all. Perhaps the sky would be too changeable, too unreliable, too mysterious to hang a story on. And that would be a quieter world in some ways. A world with a different imagination. A world that had to find other canvases for its oldest stories. But maybe the stories wouldn't disappear. Maybe they would just change shape. Literature and folklore might describe the stars not as fixed lights in the sky, but as travelers. Wanderers moving across the heavens on journeys of their own. Here tonight, gone tomorrow, passing through on their way to somewhere else. That's a beautiful idea, actually. The stars as wanderers. The sky as a road. Think about the stories that image would generate. A star that lingers for several nights near one part of the sky before moving on. Perhaps it is resting. A bright star that appears suddenly in a part of the sky that had been dim for weeks. Perhaps it has arrived from a long journey and has news to share. A tight cluster of stars gathering briefly before dispersing. Perhaps they are meeting, consulting, deciding something that will shape the nights to come. In our world, the planets are sometimes called wandering stars. In ancient Greek, the word planet literally means wanderer, because unlike the fixed stars, the planets do move visibly over time, drifting slowly through the constellations. That wandering quality made them special, made them worth watching, made them the subjects of extensive mythology and, eventually, astrology. In a sky where every star wandered, that quality would extend to all of them. Every light in the sky would be a traveler, and the sky itself would be less like a ceiling and more like a great open road, stretching in all directions, full of movement and purpose and the quiet drama of things going somewhere. The poetry written about that sky would be extraordinary, full of motion and longing and the particular melancholy of watching things pass through and not stay. Now let's think about something a little larger, about faith and meaning and the way human beings have always searched the sky for messages. Some religions could interpret the changing heavens as ongoing divine communication. Not predictable astronomical phenomena to be cataloged and explained, but active, living messages. Things being said to the world, night after night, in a language that required constant interpretation. In our world, there are religious and spiritual traditions that read meaning into astronomical events. An eclipse, a comet, a planetary conjunction. These feel significant partly because they are rare against the backdrop of a stable sky. The sky is usually the same, and so when it changes, that change feels like a signal. In a sky that changed every night, everything would be a signal. Every arrangement of stars would be a new message. Every gathering of brightness, every strange clustering, every dramatic rearrangement would be something to be interpreted, something to be read by those with the knowledge and the calling to read it. Imagine what that would do to religious life. The priests or scholars or spiritual leaders responsible for reading the sky would have an endless, never-repeating text to work with. Every morning they would wake up having seen something the night before that no human being had ever seen, and they would have to make sense of it by nightfall. That is an enormous responsibility, and an enormous imaginative task. Perhaps in that world, there would be vast institutions built around the nightly reading of the sky. Scholars who did nothing else. Libraries full of records of past sky messages, consulted for patterns, for precedents, for any hint of what the changing heavens were trying to say. The sky would be less like a clock and more like a scripture. Never finished, never fully understood, always offering something new. Breathe. Let the weight of the day dissolve a little more. You're doing beautifully. Just rest and listen. Now here is a smaller, more specific consequence and a slightly wry one. Astrologers would have to rewrite their charts constantly, since the traditional positions of stars and constellations would never remain the same. Astrology in our world is built on a very specific set of fixed relationships. The positions of the constellations relative to the sun at different times of year. The signs of the zodiac, each one corresponding to a band of sky where particular stars are found. All of it grounded in the assumption that those stars, those constellations, are where they are and will stay where they are. In a sky that rearranged itself every night, the entire astrological system would need to be rebuilt from scratch. Daily, in principle, the sign you were born under would be different depending not just on the date but on the exact hour, since the stars might be in different positions by midnight than they were at dusk. There is something almost comic about this image. The astrologer each evening heading out to look at the new sky, chart paper in hand, starting over, trying to find the constellations that define the signs and discovering that they've scattered themselves into completely new shapes, trying to determine which sign the sun is currently moving through when the stars around the sun look nothing like they did last week. In a practical sense, it would be impossible. The system would collapse. There would be no fixed zodiac because there would be no fixed stars to define it. Perhaps astrology in that world would become something else entirely. Not a system of fixed signs and houses, but a practice of daily reading, of interpretation, of looking at whatever the sky offered on the night of your birth and finding meaning in that particular arrangement, unrepeatable, belonging to you alone. Perhaps, in its own strange way, that would make it more personal. Your sky, nobody else's. The stars on the night you were born, arranged in a way they had never been arranged before and would never be arranged again. Let's step outside. Not into the cold, just in your imagination. Stand in front of something old and stone and made to last. Ancient monuments designed to align with specific stars might lose their purpose as those stars shifted away from their expected positions. There are structures on this earth built with astonishing astronomical precision. Newgrange in Ireland, older than Stonehenge, older than the pyramids, oriented so precisely that on the winter solstice, and only on the winter solstice, the rising sun fills its inner chamber with light. Stonehenge itself, aligned to the midsummer sunrise and midwinter sunset. The pyramids at Giza, their shafts aligned to specific stars. The caracol at Chichen Itza, its windows positioned to frame the rising and setting of Venus. All of these structures are expressions of a relationship between human beings and the sky. They say, we noticed you, we measured you, we built something that remembers the exact angle of your light at this moment, this day, this alignment. We wanted to hold on to it. In a sky that moved every night, that intention would be heartbreaking to maintain. You could still align a monument to the solstice sun. The sun, unlike the stars in our imagined sky, follows a consistent path. But the star alignments, those careful arrangements of stone designed to frame a particular star at a particular moment, those would fall apart within days. The star the ancient builders oriented their chamber toward would have wandered away. The alignment would no longer align with anything. You might imagine monuments in that world built differently, not to capture a specific alignment but to open to the whole sky. Wide, unroofed spaces, places designed not to frame a particular star but to receive whatever the sky offered on any given night. Places of openness rather than precision. That would be a different kind of monument, a different kind of devotion, less about holding the sky still and more about welcoming whatever it brought. Something gentler now, something domestic. The changing stars could make the night feel less predictable, potentially influencing how often people ventured out after dark. This one is easy to overlook but worth sitting with. In our world, the night sky is familiar. Even if you don't know the names of the constellations, you know roughly what to expect. A dark sky, some stars, maybe the moon, the same broad landscape of light you've seen all your life. There's a comfort in that familiarity that you might not notice until you imagine it gone. A sky that looked completely different every night would have a different emotional texture. For some people, that would be thrilling. Every night an adventure, every glance upward a discovery. Those people would love the dark, would seek it out. But for others, the unpredictability would carry a different feeling. Not comfort, but unease. The sky is one of the largest things in your perceptual world. It takes up half of everything you can see. If it's familiar, the world feels familiar. If it's strange, the world feels strange. In earlier times, before electric light, the night was already a more significant and more challenging environment than it is for most of us today. Adding a sky that looked alien and different to that already unfamiliar darkness might have kept more people inside. Might have made the night feel like a less hospitable place. Or perhaps the opposite. Perhaps the ever-changing sky would have drawn people out precisely because of its strangeness. The way a storm draws people to windows. The way anything dramatic and beautiful and slightly beyond comprehension pulls human attention toward it. Probably both in different people, in different moods, on different nights. Here is something quietly touching. Children learning about the night sky would have difficulty recognizing specific constellations because those patterns would rarely last more than one evening. In our world, one of the gentler rituals of childhood is being taken outside on a clear night and shown the sky. A parent or grandparent pointing up saying, "Do you see those 3 stars in a row? That's Orion's belt." And then the next week, going out again and finding those same 3 stars and feeling the small satisfaction of recognition. There they are again. I know those. That accumulation of small recognitions is how children learn the sky. Slowly, over years, the same patterns appear again and again until they become like old friends. Until stepping outside on a clear night feels like stepping into a room full of familiar faces. In a sky that changed every night, a child might never have that experience. They might go out with their parents on Monday and see one arrangement, and go out again on Tuesday to find it completely different. The stars they learned last night are nowhere to be found. There is nothing to recognize, nothing to return to. Learning the sky in that world might be less about recognition and more about openness. Less about knowing and more about wondering. Every night a fresh start. Every night a sky that nobody, not the child, not the parent, not the greatest astronomer alive, had ever seen before. There is something beautiful in that, alongside the loss. A childhood spent not learning fixed facts but learning to be comfortable with uncertainty. Learning that the sky is not a thing to be mastered but a thing to be met, fresh, each time. And here is a small, modern, almost playful consequence. Planetariums would need to update their projections every single day to match the latest appearance of the heavens. The whole purpose of a planetarium, the reason those great domed buildings exist, is to show you the sky as it is and as it was. To recreate the ancient sky, the sky of a particular date in a particular city, the sky as it will look a century from now. They can do this because the sky is predictable, because the mathematics of celestial movement is well understood and very reliable. In a sky that rearranged itself nightly, a planetarium's projection from yesterday would be useless today. Every morning, someone would have to go out, look at what the sky had become, record it, and load it into the system. The planetarium would become less like a library and more like a newspaper, a daily record of what was up there last night, already out of date by the time it opened. Perhaps they would become something different entirely. Not places to show you the sky of the past, but places to process the sky of the present. Spaces where last night's arrangement was analyzed and discussed and marveled at before the next night brought something entirely new. The concept of a permanent night sky would disappear, making each generation's view of the cosmos unique and impossible to fully repeat. In our world, the night sky is one of the few things that genuinely connects us across time. The same stars that you can see tonight were seen by Shakespeare, by Cleopatra, by the first human beings to stand upright and look upward in curiosity and wonder. There is an unbroken thread running from that first upward glance to this one. The same sky returned to generation after generation. In a world where the stars moved every night, that thread would not exist. Your sky would belong to you alone. Your children would grow up under a different sky, their children under another. No generation would inherit the sky of the one before it. Each view of the cosmos would be unique, unrepeatable, a gift given once and never again. That is a more solitary sky in some ways, a sky that separates rather than connects, that makes each life a little more sealed off, a little more its own island in time. But it is also, in its own strange way, a more generous sky. It gives each generation something no one has ever had. A cosmos that is, for that brief window of nights, entirely their own. And maybe there is something in that worth holding gently. The idea that what we see, from where we stand, at this moment in time, is ours in a way that nothing else quite is. The sky above you tonight is, in the truest sense, a gift given to this moment, to these eyes, to this particular sliver of human history. And that, quiet and vast as it is worth lying still for a while and just receiving. We've spent some time in the dark, in the loss, in all the things that a shifting sky would take away from us. The maps, the myths, the monuments, the thread of recognition running from one generation to the next. But human beings are not only creatures of loss. We are, perhaps more than anything else, creatures of adaptation, of creativity, of finding, in whatever world we are given, something worth paying attention to, something worth celebrating, something worth building around. So let's turn the sky over. Let's look at the other side of it. Because a sky that changed every night would not only take things away, it would give things too. Strange things, unexpected things, a whole new set of reasons to look up. Start with something simple, something almost instinctive. When human beings encounter something remarkable, they write it down. People in this world might develop a tradition of recording each night's unique star patterns, creating vast archives of ever-changing celestial maps. Not the static, authoritative atlases of our world, the ones that remain accurate for centuries because the sky they describe doesn't move, but living archives, growing archives. A new page was added every single night, everywhere on Earth, by everyone who looked up and thought, I want to remember this. Imagine what those archives would look like after 100 years. 1,000, shelf upon shelf of sky records, each one different, each one a snapshot of a night that could never be reconstructed. Millions of unique arrangements, documented in whatever medium the culture of the time could manage. Stone carvings in the earliest centuries, ink on parchment in the medieval period, digital files in the modern era, uploaded automatically by arrays of cameras pointed permanently at the sky. The archive would be one of the largest, most complex documents in human history, and also one of the most beautiful, a record not of what the sky was, permanently and unchangingly, but of what it had been night after night, in its endless reinvention of itself. Scholars would spend their careers in those archives, looking for patterns within the chaos, wondering if there were cycles, if certain arrangements recurred after long enough intervals, if the sky had something like a memory. Probably they would never find a satisfying answer. Probably the archive would remain what it was, a record of pure variety, a document of the unrepeatable. But the act of keeping it, the daily discipline of looking up and writing down, that would be worth something in itself. A world that kept a nightly diary of its own sky would be a world paying very close attention to the night. And a world paying close attention to the night is a more awake world, a more present world. Let your breathing slow down. Let your thoughts go wherever they want. Not everyone in this world would engage with the sky through institutions and archives and official records. Some of the deepest knowledge would live in quieter places. People living in remote regions, far from cities, far from artificial light. People whose nights were genuinely dark and whose skies were genuinely clear. Those people might become extraordinarily skilled at reading the nightly movements of the stars, highly attuned to patterns that more casual observers would never notice, developing an intimacy with the sky that would be almost impossible to describe to someone who hadn't lived it. We see something like this in our own world. Communities that live close to the land, whose lives are genuinely shaped by the rhythms of the natural world, often develop a sensitivity to those rhythms that people in cities simply don't have. A farmer who has watched the same fields through 50 seasons sees things in the weather that a weekend visitor would walk right past. A fisherman who has spent decades reading the sea carries knowledge in their body that no textbook contains. In a world with a shifting sky, that kind of embodied, accumulated, lived knowledge would apply to the night. The person who had spent years watching the stars change, who had been out every clear night for decades, recording and comparing and simply looking, would develop an intuition about the sky that would be genuinely rare. They might not be able to predict it, no one could predict it, but they would notice things, subtleties, tendencies, the way certain arrangements seem to cluster, the way certain regions of the sky seem to attract more activity on certain kinds of nights. That knowledge would be precious, the kind of knowledge that communities would gather around. That would be sought out, consulted, passed down. Not because it was always useful in the practical sense, but because it was deep. Because it came from a lifetime of showing up and paying attention. And there is something quietly admirable about that. About the person who, in a world that gave no fixed stars to learn, chose to learn the unfixed ones anyway. Choose to be present night after night for whatever the sky decides to offer. Now let's move from the remote and the contemplative to something a little more energetic. Amateur stargazing in this world would become a constantly evolving hobby, driven by something that our own stargazing, wonderful as it is, can never quite offer: the possibility of genuine discovery. In our world, when an amateur astronomer looks at the night sky, they are looking at something that has been mapped exhaustively. Every visible star cataloged, named, measured. Every constellation has been documented for thousands of years. There is great beauty in it, and there is real science to be done, particularly around variable stars and transient events. But the fixed background, the basic arrangement of the sky, holds no surprises. It is what it is, and it is well known. In a sky that rearranged itself nightly, every amateur observer would be looking at something genuinely new. A formation that nobody had documented. An arrangement of stars that had never been seen before in the history of human observation. The possibility of seeing something remarkable, something unprecedented, would be real every single night. That would change the character of the hobby entirely. It would have a kind of electricity to it, competitive edge almost. Who spotted the most unusual formation last night? Did anyone else see that extraordinary cluster in the eastern sky just after midnight? Was there a name yet for that bright, tight grouping near the horizon before dawn? Online communities would be vast and deeply engaged, not just sharing photographs of familiar objects as our astronomy communities do, but racing to document the new, to describe and name and map formations that had never existed before and would never exist again. Every clear night would generate thousands of new images, new records, new observations from amateur observers all over the world, all of them looking at different parts of a different sky, all of them holding a piece of something that would not last. It would be one of the most genuinely participatory sciences in history, not because amateurs were filling in gaps that professionals hadn't gotten to yet, but because the sky was simply too vast, too varied, too constantly changing for any professional institution to keep up with it alone. You would need everyone, every pair of eyes, every garden with a clear view of the sky. You would need the whole world looking up, and perhaps the world would begin to organize itself around that looking up. Perhaps it would find its way into the daily rhythms of ordinary life. Schools might begin each day by discussing the previous night's star patterns, much as people currently discuss unusual weather events. The teacher arrives in the morning, the children coming in from home, and the first question of the day being not a test or a lesson but a conversation. What did you see last night? Did anyone go out after dark? What was the sky doing? Think about what that daily conversation would do over time. It would make the night sky a shared cultural reference, something everyone had in common, the way weather is something everyone has in common now. You talk about the weather not just because you need to know whether to bring an umbrella, but because it is a shared experience, a piece of the world that everyone inhabits simultaneously, a neutral and available subject that connects people across otherwise different lives. The sky in this world would do that. Every morning, a fresh topic. Every morning, a reason to compare notes, to describe what you saw, to find out whether your neighbor's sky looked like yours, to learn that someone 3 streets away saw something completely different because the clouds cleared later for them or because they were looking in a different direction. Children would grow up sky literate in a way that most children in our world are not. Not because they were taught formal astronomy, though perhaps they were, but because the sky was simply part of the daily conversation, part of what it meant to be a person moving through the world. And that literacy, that easy familiarity with looking up and noticing and discussing what you saw, would shape those children in ways that are hard to quantify. A generation that paid attention to the sky would be a generation that paid attention. Full stop. The habit of noticing, of looking carefully, of comparing what you saw with what someone else saw and trying to understand the difference, that is not a small habit. That is a way of being in the world. Rest a little. Let your body be heavy and still. The script is gentle tonight. Just voices and sky. Now let's think about how this world would communicate. Newspapers and websites, or whatever served those functions in earlier eras, pamphlets, town criers, message boards, could feature daily sky reports. Not weather forecasts, something different, something more wondrous. Descriptions of the most remarkable stellar formations visible around the world the previous night, compiled from observers everywhere, assembled into a picture of what the sky had offered. Imagine reading one of those reports over breakfast. Last night in the southern hemisphere, observers reported an extraordinary concentration of first-magnitude stars in the western sky just after sunset, forming a rough arc of unusual brightness. In northern latitudes, a loose but striking grouping near the zenith was widely photographed and described by multiple observers as resembling no previously recorded formation. Meanwhile, along the equatorial band, the usual scattered distribution gave way briefly to a striking emptiness in the north, with stars clustering heavily toward the south. That report would be read the way we read weather news. With interest, with curiosity, with the particular pleasure of knowing that the world you share with other people is full of things worth noticing. and it would connect people. People on opposite sides of the planet, who would otherwise have no reason to feel they were experiencing the same night, would be linked by the sky they had both looked up at. Different parts of it, yes. Different arrangements, because the sky looks different depending on your latitude. But the same night, the same turning of the Earth through the same field of moving stars. The daily sky report would be one of the great connective tissues of that society. A shared text, something everyone read, something that made the world feel like a common place, inhabited together under a sky that belonged to everyone. And if the sky could be reported, it could also be forecast, or something like a forecast. Entire professions could arise around the attempt to predict the next night's stellar arrangement, much as meteorologists forecast the weather today. The word attempt is doing some work there, because unlike weather, which follows physical laws that, in principle, can be modeled and predicted, a sky that rearranges itself randomly, if that's what it does, would resist prediction entirely. No model would capture it. No equation would tell you where a given star would be tomorrow night. But perhaps it wouldn't be entirely random. Perhaps there would be tendencies, statistical regularities. The sky equivalent of knowing that a certain kind of pressure system usually means rain without knowing exactly where each raindrop will fall. Stellar forecasters would be working in that space, not claiming to know exactly what the sky would look like tomorrow, but offering probabilities. A higher than usual chance of a dense concentration in the southern sky. An elevated likelihood of an unusually bright arrangement near the horizon just after dark. A quiet night expected, with stars distributed relatively evenly. Those forecasters would be celebrities of a kind. The good ones, the ones whose probabilities turned out to be reliable more often than chance would explain, would be famous. Their morning forecasts would be cited, debated, compared with what the sky actually did come nightfall. Their mistakes would be noted and their successes celebrated. And the science behind their work, the attempt to find patterns in what might appear to be pure chaos, would drive some of the most interesting mathematics and astronomy that the world had ever produced. Because the desire to predict the sky is very old and very deeply human, and in a world where the sky was genuinely hard to predict, that desire would be sharper, and the rewards of even partial success would be enormous. Let's step briefly into the modern version of this world. Skywatching apps in a sky like this would look nothing like the ones we have. Ours are elegant and useful precisely because the sky is fixed. You point your phone upward and it tells you what you're looking at, because what you're looking at is exactly where it has always been and will always be. The app knows the sky because the sky doesn't change. In a world where the stars moved every night, those apps would need to update continuously. Fresh star maps every evening, compiled from a global network of observations made the previous night, distributed to every device, ready for the first person who stepped outside after dark. The logistics of that would be extraordinary. A global, real-time sky mapping operation running every day without fail, taking in data from thousands of observation points, processing it, reconciling the different views from different latitudes, and producing a unified picture of the night sky as it currently stood. The app on your phone would not tell you what the sky always looks like. It would tell you what the sky looks like tonight. Only tonight. And tomorrow night it would be different, and the app would know because somewhere on the other side of the world, in daylight while you slept, someone had already looked up and recorded what was coming. There is something almost alive about that image. A planetary nervous system, attentive to the sky, passing the information around the globe, always just ahead of the dark. And where there is something extraordinary to see, there will always be people who travel to see it. The tourism industry in this world might build itself, at least in part, around the sky. Special destinations, remote places with dark skies and clear horizons, would become pilgrimage sites of a kind. Not because the sky there was always better, though with less light pollution it would always be clearer. but because those places would be the best places to receive whatever the sky was currently offering. You would book a trip not to see a specific thing the way you might travel to see a particular landmark, but to be in the best possible position to see whatever was there. To give yourself the clearest view of the unknown. That is a different kind of tourism. Less about the destination in itself and more about the conditions for reception. Less about going somewhere to see what you expect and more about going somewhere to be surprised by whatever arrives. Entire communities in those dark sky regions might build their economies around it. Accommodation with roof terraces and unobstructed horizons. Guides who knew the local sky, who could help visitors find the best vantage points, who could explain what they were seeing in the context of what had been seen in previous nights. A whole culture of sky hospitality, warm and knowledgeable and deeply attuned to the dark. And finally, two thoughts that belong together. The night sky in this world could become one of humanity's most shared experiences. People everywhere, every evening, comparing notes. What did your sky look like last night? Did you see that bright gathering in the east? Was it visible from where you were? That conversation happening across every culture, every language, every time zone, would weave something between people that is hard to name but easy to feel. A sense of common experience, of sharing a world, of being together beneath something vast and strange and beautiful that none of you fully understand. And within that shared experience, something more intimate would also be happening. Couples might gather on clear nights to witness particularly beautiful arrangements of stars, turning celestial viewing into one of the great shared social rituals of that world. Not just couples, but friends, families, communities. People spread blankets in gardens and fields and on rooftops. People lying on their backs in the dark with someone they loved, looking up at a sky that had never looked like this before and would never look like this again. There is something about impermanence that intensifies feeling. The reason a sunset is moving is partly because it's leaving. The reason a piece of music feels significant is partly because it's passing through time, never the same twice, gone the moment it arrives. A sky that changed every night would carry that quality in everything it showed you. Every beautiful arrangement of stars would be a thing you were seeing for the first and last time. Every gathering of light in the dark, every temporary superconstellation, every quiet, ordinary night of scattered stars would belong entirely to that moment, to that evening, to whoever was outside, lying in the grass, looking up. You couldn't photograph it and come back to it. You couldn't show it to someone who missed it. It was there, and then it was the past, filed away in the great archive of nights that had been and would not come again. And so you would look, you would really look, the way you look at things you know you can't keep, the way, perhaps, we should all be looking at the sky tonight. There is a particular kind of event that lodges itself in human memory and refuses to leave. Not the everyday things, not the ordinary beautiful things, but the ones that arrive once, fully formed, and then are gone. The ones that people who were there describe for the rest of their lives with a specific quality in their voice. A quietness, almost. The way people talk about things that were so large, so complete, so beyond the usual scale of experience that the memory of them sits in a different category from everything else. A total solar eclipse is like that. People travel thousands of miles for the minutes of totality, and then spend years afterwards trying to describe what it felt like. A great comet, blazing across the sky for weeks before fading. The aurora borealis is seen unexpectedly, on a night when the conditions were perfect, filling the whole sky with light. These things become landmarks in life, before the eclipse and after it. The year the comet came, in a sky that rearranged itself every single night, events like that would be far more common. And perhaps because of that, they would be woven even more deeply into the fabric of how a society remembered itself. Certain star patterns might become famous historical events, remembered for generations much like eclipses or comets are today. Think about what that means for the texture of history in that world. In our world, historical time is marked by human events. Wars, revolutions, discoveries, the births and deaths of significant people. The sky punctuates that history occasionally, a notable eclipse, a comet that appeared during a siege and was taken as an omen, a meteor shower that lit up the night before a famous battle. But those sky events are rare interruptions in a history that is otherwise purely human. In a world with a shifting sky, the sky would be a constant participant in history. Not just an occasional interruption, but a regular contributor. The night of the Great Gathering, when 1,000 bright stars clustered in the southern sky and people across an entire continent came outside to stare. The winter of the dark years, when for several weeks the stars distributed themselves so thinly that the nights were genuinely, unsettlingly empty. The morning after the crown, when a formation so perfectly circular appeared that people simply could not believe it was random, and spent the following years debating whether it was. Those sky events would enter the language, would become reference points. It would be the kind of thing that when mentioned in conversation, the older people in the room would nod and say, "Yes, I remember that. I was 7 years old. My father woke me up to see it." The sky would be part of the lived texture of generational memory in a way that, in our world, it almost never is. History in that world would smell faintly of night air, would carry within it the memory of countless upturned faces. Let's think about the most extreme version of this. The record breakers. The nights that would become legendary not just in one community but everywhere. Record-breaking celestial events could occur when hundreds of bright stars temporarily aligned to form striking geometric shapes in the sky. Perfect triangle. A vast, unmistakable cross. A circle so clean it seemed drawn by something with intention and a steady hand. The universe does not, in reality, deal in perfect geometry. The shapes we see in our constellations are loose, approximate pareidolia as much as pattern. We see what we want to see, and we call it a bear or a hunter or a queen. But in a sky where the stars moved freely every night, genuine geometric arrangements would occasionally occur by pure chance. Not often, not reliably, but given enough nights, given the sheer combinatorial vastness of all the possible arrangements those stars could fall into, a night would come, eventually, when something appeared in the sky that looked less like coincidence and more like intention. A straight line of a dozen bright stars, evenly spaced across the sky. A near-perfect equilateral triangle of first-magnitude lights. Something that made people stop and point and reach for whoever was nearest to them and say quietly, "Are you seeing this?" Those nights would become the stuff of legend. They would be the events that the archives were most eagerly searching for, the nights that historians and astronomers and ordinary people with an interest in the sky returned to again and again, studying the records, trying to understand exactly what had happened and whether it could possibly happen again. And occasionally, when the forecasters' models suggested that something geometrically remarkable might be building, when the probabilities tilted toward the extraordinary, the anticipation would be enormous. Your breathing is slow and even. The night is doing what nights do quietly, all around you. Stay here a while. Certain star configurations might become globally famous, attracting millions of viewers whenever predictions suggest they could appear again. This is a world that has learned, through long experience, that the sky occasionally produces something extraordinary. And it has also learned that extraordinary things, while never truly predictable, have tendencies. Statistical shadows. The forecasters can't tell you that the Great Arc will return on Thursday. But they can tell you that the conditions that have historically preceded large, coherent formations are present right now. That the next week is worth watching. That if you're going to be outside and looking up, this might be the time. And when that word goes out, people listen. The movement of people toward dark skies ahead of a predicted remarkable event would be one of the great spectacles of that world. highways leading away from cities, filling up in the evenings with people driving toward higher ground, toward open fields, toward the dark sky destinations built for exactly this purpose. Hotels are full. Roadside spots occupied by families with blankets and flasks of something warm. Entire hillsides populated with upturned faces, waiting. And sometimes the sky would deliver, would produce something that matched or exceeded what the forecasters had hinted at. And the communal experience of being there for that, of being one of the millions who happened to be looking up at the right moment, would be the kind of thing that stayed with a person for the rest of their life. And sometimes the sky would offer something quiet and ordinary, and the crowds would go home gently, not disappointed exactly, just reminded that the sky kept its own counsel, delivered on its own terms, and could not be reliably summoned by human expectation. Both experiences would be valuable in their different ways. Now let's follow this idea into something even more communal, into celebration, into the way that human beings take the remarkable things that happen to them and build ritual around them. Many cultures might celebrate the appearance of rare star formations that occur only once in centuries before disappearing again. Once in centuries. Think about what that means. A formation so unusual, so far outside the statistical norm, that it appears perhaps twice in the entire recorded history of a civilization. Something that the very oldest records mention, that grandparents heard about from their grandparents, that exists in the culture as a legend almost, a thing that happened once long ago that might happen again. When it did happen again, the event would carry all of that weight. All of those generations of waiting and wondering and hoping to be the ones who were alive when it returned. The celebrations that erupted around such an event would be unlike anything else in that culture's calendar. Not just a festival in the usual sense, a thing that happens annually and is beloved and anticipated but also quietly taken a little for granted. Something categorically different. A once-in-generations event. A night that people had been born hoping to see and had not been certain they would live to see. The celebrations would begin before the night itself. Days of preparation, of gathering, of the whole weight of cultural memory being brought to bear on the present moment. And then the night. And then, if the forecasters were right, if the sky delivered what the models had suggested it might, the actual sight of it. Rising in the dark. Unmistakable. Rare as anything that deserved the name. The generation that witnessed it would carry it forward. Would tell their grandchildren. Would make sure it was recorded, honored, remembered, so that when it came again, however many centuries hence, there would be a culture ready to receive it. Breathe gently. Let your mind drift with the current of this. There's no destination tonight, just the slow movement of ideas in the dark. Entire festivals could be organized around the predicted arrival of especially rare and spectacular nightly star configurations. Festivals of anticipation. That's what they would be at their heart. Not just celebrating something that had already happened, but collectively leaning towards something that might happen. The uncertainty part of the festival. The possibility built into the ritual. We have something like this in our world, with meteor showers. The Perseids in August, the Leonids in November. You know the dates, you go out, and you hope for a clear night and a show worth watching. There is a gentle communal pleasure in it. Checking the forecasts, finding a dark spot, lying on your back with friends. Scale that up by an order of magnitude. Replace the familiar annual meteor shower with an event that might be genuinely unprecedented. Give it the weight of a sky that has been changing every night for as long as anyone can remember, and the cultural knowledge that sometimes, rarely, it produces something that takes the breath away. Build a festival around the possibility. The music played at those festivals would be different from any other music. The food, the gathering, the particular way people would talk on those nights, quieter than usual and more attentive, would have a character that no other occasion in the calendar possessed. And even on the nights when the sky offered nothing unusual, when the predicted formation didn't materialize, when the stars distributed themselves in an ordinary way and the gathered crowds looked up at something lovely but unremarkable, even those nights would have something. The warmth of the people gathered, the shared willingness to have hoped, the not quite disappointment of a world that had learned to hold its expectations lightly, because the sky could not be made to perform on demand, and there was a kind of respect in accepting that. Now let's move from the communal to the individual, from festivals and crowds to the solitary experience of a single person in front of a blank canvas, or an empty page, or an untuned instrument, trying to make something from what the night gave them. Poets, artists, and musicians would find endless inspiration in a sky that created a new masterpiece every single night. This is perhaps the most straightforward gift that sky could offer, and also the most profound. Because the problem that every artist faces in every era, in every medium, is the problem of the subject. What to make something about. Where to find the image or the feeling or the idea that is worth the effort of making it into art. In a world with a shifting sky, every artist would have an inexhaustible subject waiting for them every night outside their door. Not just the literal appearance of the sky, not just paintings of star formations, though there would be many of those, but all the feelings that a sky like that would generate. The wonder and the impermanence and the longing and the strangeness of living under something so vast and so indifferent and so relentlessly new. The way it would make you feel small in some moments and, in others, extraordinarily present. The way it would make the night feel charged and alive. A poet who had grown up under that sky would have a different relationship to impermanence than a poet in our world. It would write about it differently, would have been educated by it, in the wordless way that the sky educates, into an understanding that things pass and that this is not simply a tragedy but a condition of beauty. A composer who had spent years listening to the sky, in the metaphorical sense that artists listen to everything, would make music that carried that quality of nightly reinvention. Pieces that never quite resolved. Structures that shifted just when you thought you had them figured out. Music that felt like it was always becoming something, never quite arriving. The art of that world would be different from ours. Wilder, maybe, less attached to permanence. More comfortable with the beautiful and the fleeting being, in the end, the same thing. And the artists would not only make new work, they would also preserve what had been. Artists could create vast collections inspired by famous nightly skies, preserving beautiful stellar formations that appeared only once in history. The archive of nightly skies would be a scientific document, exact, measured, recorded with instruments. But alongside it would grow another kind of archive, an artistic one. Paintings of the most celebrated nights, musical compositions written in response to particular formations and named after them. Poems that tried to catch, in language, the quality of light on a specific night in a specific sky above a specific place. That artistic archive would be a different kind of preservation. Not the exact data of where each star was, but the felt experience of being there. The human response. The texture of what it was like to be alive on that particular night and look up. Future generations, returning to a famous night in the archive, would have both. The precise record and the emotional one. The star map and the painting made by someone who wept when they saw it. There is something moving about that. The idea that the record of the sky would not only be scientific but also personal. That the data and the feeling would be kept together. Neither one considered sufficient without the other. The sky as both fact and feeling, both coordinate and poem. And here is the thought that follows naturally from all of this preserving and recording and archiving. Future generations might be able to replay the sky from any date in history, viewing long-lost stellar arrangements much like we watch old photographs today. The technology for this, in a sufficiently advanced version of that world, is not difficult to imagine. A complete database of every recorded night sky, going back as far as the records extend. A projection system capable of recreating any of those nights in sufficient detail that you feel you are standing under them. And the simple human desire, as old as any desire, to see what the past looked like. People would use it the way we use old photographs, to look at what was, to try to feel, even at a remove, something of what it was to be in a particular moment that is now irretrievably gone. They might replay the sky of the night a famous person was born, or the night a great battle was fought, or simply a night that the records described as especially beautiful, that had entered the cultural memory as a benchmark of what the shifting sky could produce when it was at its most extraordinary. And they would sit in the recreated dark, with the recreated stars wheeling overhead in their unique and unrepeatable arrangement, and they would feel something. Not quite what the original observers felt, because the original observers had the cold and the smell of night air and the beating of their own hearts. But something, a reach across time, a sense of standing briefly under a sky that someone long dead had also stood under and found worth remembering. Over thousands of years, in this world, humanity would accumulate an enormous archive of nightly star maps, one of the largest observational records ever assembled, a document of the sky's endless variety, building night by night, year by year, century by century, into something almost incomprehensibly vast. And within that archive, a kind of knowledge that would have no parallel in our world. A knowledge not just of what the sky was, as our astronomical knowledge is, but of what the sky had been. All its moods and configurations. Its ordinary nights and its spectacular ones. Its quiet, thin-starred evenings and its blazing, crowded, impossible nights. A knowledge of the sky as a changing thing. A knowledge that could only be gained by watching it change, faithfully and patiently, for a very long time. And finally, the thought that holds all of this together. Humanity's relationship with the cosmos in this world might become more personal than it is in ours. In our world, the cosmos is magnificent and scientific and awe-inspiring, but it is also, in a fundamental way, out there. A thing that exists on a scale and in a mode that has very little to do with individual human experience. You can look at it and feel humbled by it. You can study it and feel the particular pleasure of understanding. But it doesn't know you're there. It doesn't offer you anything different from what it offers everyone else. A shifting sky would change that relationship. Not because the sky would actually be aware of you, but because every night would offer something that no previous generation had seen. Your sky, this generation's sky, the particular cosmic scenery of this moment in history, belonging to the people alive to see it in a way that no arrangement had ever belonged to any generation before. That is a more intimate cosmos. A cosmos that, through sheer constant novelty, manages to feel like it has something to say to you specifically, to your moment, to the particular combination of people and events and feelings that make up the world right now. Every night, a new sky. Every night, a gift is given to the people alive to receive it. Every night, the universe, vast and indifferent and ancient as it is, offers something that has never been offered before. And perhaps that is not so different from our world, if you look at it in a certain way. Perhaps the sky above you tonight, which looks so fixed and familiar, is also offering you something it has never quite offered before. The particular combination of clouds and clearness, the moon at this precise phase, the hour and the season and the air between you and the stars. Nothing has ever been exactly this sky, for exactly this moment, seen by exactly these eyes. And tomorrow night it will be different again. We have spent a good while now in the human world, in the stories and the festivals and the archives and the art, in all the ways that people would respond to a sky that refused to stay still. But the sky does not exist only for people. Long before the first human being stood upright and looked up in curiosity, Long before the first story was told or the first star map scratched into stone, the night sky was already doing something, already being used, already embedded into the machinery of life on this planet in ways that had nothing to do with wonder or navigation or the desire to find meaning. The natural world found its way to the stars long before we did, built its rhythms around them, wove them into the deep biological logic of migration and movement and survival. And so a sky that changed every night would not only disrupt human civilization, it would reach down into the very fabric of life on Earth, into the nervous systems and instincts of creatures that never named a star or told a story about one, and it would disturb something ancient and essential there too. Begin with birds, because birds, in their navigational intelligence, are one of the true marvels of the natural world. Every year, billions of birds make journeys that should, by any reasonable measure, be impossible. Tiny warblers crossing the Sahara. Arctic terns travel from one pole to the other and back again. Shorebirds flying non-stop from Alaska to New Zealand. These journeys are made not with maps or instruments but with something built into the bird itself. A suite of navigational tools so sophisticated that scientists are still working to fully understand them. And among those tools, for many species, is the night sky. Birds that migrate at night, and many do, use the stars to orient themselves. Not by tracking a single star the way a human navigator might use Polaris, but by recognizing the rotation of the sky, by finding the still point around which the stars appear to turn, and using that to identify north. They learn this remarkably as nestlings, watching the night sky from the nest before they ever fly, imprinting the pattern of stellar rotation so deeply that it becomes part of how they understand direction. In a sky that rearranged itself every night, there would be no stable rotation pattern to imprint, no consistent still point. The sky would turn as it does, but what it was turning around would look different from one night to the next. The star compass that generations of birds had relied on would give contradictory information, would point in different directions on different nights, would be, for a creature trying to fly from one continent to another, worse than useless. Wildlife that uses stars for navigation, such as some migratory birds, could become confused and struggle to follow traditional migration routes. Confused is a gentle word for what might happen. Birds that arrived at their wintering grounds weeks late, having spent that time drifting and correcting and losing confidence in their own instincts. Birds that ended up in the wrong hemisphere. Population collapses among species whose migrations were long and dangerous enough that even small navigational errors meant death. Evolution, given time, would find a way through. It always does. Birds that relied more heavily on magnetic sensing, on landmarks, on the position of the sun at dawn and dusk, would do better. And over generations, the star navigation component would diminish or adapt. But that adaptation would take a very long time. And in the meantime, the sky would be pulling one of the great navigational systems of the natural world apart at the seams. Let your body soften. Your shoulders, your hands, your face. There's nothing to hold tonight. It's not only birds. The deep, cold ocean has its own navigators. Certain species of seals and other marine animals that rely on celestial cues during long journeys might need to evolve alternative navigation methods. There is something astonishing in the idea of a seal, in the dark water, looking up through the surface at the stars. But some species do use celestial cues, along with Earth's magnetic field and their memory of landmarks, to navigate across the open ocean. Remove the reliability of those cues and these animals would be working with an incomplete toolkit. Not helpless, not immediately, but their journeys would become harder, the margins of error wider. In an ocean where getting lost means missing a feeding ground or failing to return to a breeding beach, the consequences of navigational uncertainty are serious. There is a particular kind of melancholy in imagining this. A seal surfacing at night, its dark eyes turning upward toward a sky that looks different from any sky it has seen before. The deep instinct reaching for something that isn't there anymore. Not extinct, not gone entirely, just rearranged into something the instinct can't quite read. Animals can't be curious about the sky the way we are. They can't be delighted by its nightly novelty. For them, a sky that changes every night is not a wonder. It is a problem, a disruption in the reliable fabric of a world they need to make sense of in order to survive. We would be watching the spectacle. They would be living with the consequences, even smaller, even closer to the ground. Nocturnal insects that orient themselves using the night sky could experience disruptions in their movement patterns. This is one that most people would never think of. Insects don't seem like the kind of creatures that look at stars, but many do in their way. Dung beetles remarkably use the Milky Way to navigate in a straight line. Certain moths use the moon and the general gradient of the night sky to maintain their flight direction. Even some ants have been shown to use celestial cues. These are not conscious navigational decisions. These creatures are not reading maps or calculating angles. But somewhere in the hardwiring of their nervous systems is an instruction that says, keep that light at this angle. Maintain this relationship to the brightness above you. Move in this direction relative to what the sky is doing. In a sky that looked different every night, those instructions would generate different behaviors on different nights. An insect that had been moving reliably in one direction might, on a night when the sky arranged itself unusually, find its heading wandering. Populations that depended on movement patterns for breeding, for food, for the basic logistics of insect life, might be subtly disrupted in ways that added up over generations to significant ecological changes. Small disruptions, easy to overlook individually, but insects are foundational. They pollinate, they decompose, they feed almost everything else. Disrupt their movement patterns consistently over evolutionary time, and the disruption doesn't stay small. It propagates upward through the food web in ways that are difficult to predict and harder still to reverse. The sky, it turns out, is not just above the natural world. It is inside it, woven into the biology of creatures from the largest migrating bird to the smallest dung beetle navigating by the light of our galaxy's core. Now let's rise, not just off the ground but off the planet entirely. Because a shifting sky would not only complicate life on Earth, it would complicate one of the greatest intellectual endeavors in human history, the attempt to understand the universe beyond our own small world. The search for exoplanets, for planets orbiting other stars, could become far more complicated in a sky where astronomers could not easily track the same stars from night to night. Finding a planet around another star is an extraordinarily delicate business. The methods used most successfully involve watching a star over a long period of time, measuring its light with great precision, and looking for the tiny, repeating dimming that occurs when a planet passes in front of it, or measuring the tiny wobble in the star's motion caused by the gravitational pull of an orbiting planet. Both methods require watching the same star repeatedly over months or years, building up a dataset that reveals the planet's presence through accumulated evidence. In a sky where stars moved every night, that continuity would be almost impossible to maintain. You could find a star one night, you could measure it carefully, but tomorrow night, it would be somewhere else, mixed in with stars it had never been near before, potentially indistinguishable from hundreds of others in its new neighborhood. Your long, careful dataset would have a gap, and another gap the night after that, and the gaps would accumulate until the dataset was no longer usable. The discovery of worlds beyond our own, one of the most profound scientific achievements of our era, would be set back by centuries in that world. Not impossible eventually, but requiring tools and methods that our version of the science took a very long time to develop, driven forward by a problem we never had to solve. Let the night hold you. You don't need to go anywhere. Just be here, in the quiet, and let the words move past you like water. Telescopes programmed to observe specific stars would require constant recalibration as their targets shifted across the sky. There is something almost poignant about this image. A great telescope, one of those enormous instruments perched on a mountain somewhere, precisely engineered to point to within a fraction of an arcsecond of its intended target, waking up each night to find that the thing it was built to look at is somewhere completely different. Modern telescopes are marvels of precision engineering. They can track a star across the sky as the Earth rotates, compensating for atmospheric distortion, maintaining a lock on their target that keeps it perfectly centered in the field of view for hours. All of that precision is built on one assumption: that the star will be where the calculations say it will be. In a sky that moved every night, that assumption would fail nightly. Every evening, before observing could begin, there would be a search, a re-identification of the target, a lengthy recalibration of the system. Time and resources are devoted not to doing the science, but to finding the subject of the science again, like a researcher who arrives at their lab each morning to find that all the samples have been rearranged overnight. The cumulative cost of that, across all the telescopes in the world, across all the research programs running simultaneously, would be enormous. Not just in money and time, but in lost knowledge. In the observations that couldn't be made, the data that couldn't be collected, the questions that couldn't be answered because the instruments spent too much of each night trying to find where to look. And the instruments themselves would need to think differently. Astronomers would have to create entirely new methods for identifying stars, since position alone would no longer be a reliable clue. In our world, a star's position in the sky is one of its primary identifying characteristics. The coordinates, right ascension and declination, are like a star's address. They tell you exactly where to look. Combined with brightness and color, they give you an unambiguous identification that can be verified by anyone, anywhere, on any night. In a sky that rearranged itself nightly, position would be useless as an identifier. The address would change every night. You would need to read something intrinsic to the star itself, something that traveled with it wherever it went. Its spectrum, its precise chemical signature, the way its light was distributed across wavelengths in a pattern as individual as a fingerprint. Spectroscopy, the science of reading the chemical composition of stars from their light, would become the primary tool of stellar identification in that world. Every observation would begin with a spectral reading, a check of the star's chemical signature, to confirm that the thing you were looking at was the thing you thought you were looking at. That would push the science of spectroscopy far ahead of where it might otherwise have developed, would make it more central, more refined, more richly understood. And that deeper understanding of stellar chemistry might unlock other things too. Other knowledge that flows from knowing with great precision what stars are made of. Sometimes a constraint forces the development of a tool, and the tool turns out to be useful for far more than the original problem. That might be the case here. Astronomy would develop much more slowly in this world. That much is nearly certain. The basic work of cataloging the sky, of understanding the distribution and variety of stars, of tracing the large-scale structure of the galaxy, all of it would take far longer without the ability to simply look at where things are and map them. But there would be compensations. Strange ones. A science that had always had to work harder to identify its subjects would be a more methodologically sophisticated science. A field that had never been able to take the position of a star for granted would have developed, of necessity, a richer set of tools for understanding what stars actually are rather than simply where they are. Our own astronomy benefited from centuries of careful positional work, mapping the sky, building the celestial coordinates, tracking the motions of planets. That positional foundation made everything else easier. But it also meant that for a long time, position was the primary lens through which the sky was understood. A sky that made positional astronomy nearly impossible might have pushed toward a physics-first understanding of stars much earlier. Might have gone straight to the questions of composition and behavior and physical process, driven there by the impossibility of the cartographic approach. A more difficult sky might have produced, in the long run, a more fundamental science. And it's not only telescopes on mountaintops that would be affected. Space agencies would need more advanced tracking systems to ensure spacecraft pointed toward the correct stars for navigation and observation. Spacecraft, as they travel through the solar system and beyond, use stars as reference points. The position of known stars relative to the spacecraft tells the navigation systems where the vehicle is and which direction it is pointed. This stellar navigation is one of the most reliable tools available in deep space, where the usual landmarks have dwindled to invisibility. In a sky that moved every night, the star charts that spacecraft carry would be useless within days of launch. The reference points would have shifted. The relationship between the spacecraft sensors and the stars they were designed to track would have broken down. New solutions would be required. Perhaps spacecraft would carry spectroscopic sensors capable of identifying stars by their chemical signatures rather than their positions. Perhaps navigation would rely more heavily on other methods, on the geometry of the solar system, on radio signals from known sources, on the positions of planets rather than stars. And spacecraft that use stars as reference points for orientation would need to continuously update their navigation systems to account for the shifting sky, receiving regular transmissions from Earth, updated star charts, new positions, corrections for the latest nightly rearrangement. That continuous connection between spacecraft and home would require more bandwidth, more engineering, more redundancy. Every mission would carry the additional complexity of a sky that had moved since the mission was designed. And finally, the consequences reach all the way down to the invisible infrastructure of modern life. Modern satellites could require continuous recalibration because many rely on highly accurate star trackers to determine their position in space. This is not an abstraction. Satellites are not simply objects in orbit. They are the nervous system of modern civilization. Communications, navigation, weather forecasting, financial transactions, emergency services. The list of things that depend, directly or indirectly, on satellites functioning correctly and knowing where they are is so long that it would be easier to list the things that don't. Star trackers are among the most important tools those satellites use to maintain their orientation. Small cameras pointed at the sky, continuously comparing what they see against a stored star map to determine exactly how the satellite is positioned. In a sky that changed every night, those star maps would be outdated within hours. Every satellite in orbit would need a continuous stream of updated sky information, would need to constantly re-verify its own orientation against a sky that looked different than it had yesterday. The engineering challenge of that would be immense. The cost in processing power and in the bandwidth required to maintain those continuous updates across an entire satellite constellation would be significant. Satellites that currently operate with a high degree of autonomy, doing their jobs quietly and reliably with minimal intervention, would require constant attention. The sky in that world would not be a backdrop to technology. It would be a daily participant in it, a variable, a complication, an adversary that had to be tracked and accounted for in every system that looked upward for its bearings. Technology would be more humble in that world, more aware of its own dependence on the natural world, more honest about the fact that even the most sophisticated human-made systems are built on a foundation of natural phenomena, and that when those phenomena shift, everything built on them shifts too. There is a quiet lesson in that. A reminder that we have always been more dependent on the stability of the natural world than we usually remember to acknowledge. That the fixed stars are not just beautiful. They are, in the most practical and unglamorous sense, load-bearing. They hold things up. And on a night like tonight, when everything is still and the world is quiet and the sky above you is doing exactly what it always does, there is something worth feeling in that. A quiet gratitude, perhaps, for a sky that stays. We have spent a long time now living inside this world, getting comfortable with its rhythms. The nightly rearrangement of the sky, the festivals and the archives, the confused birds and the scrambling satellites. We have been treating the moving stars as simply a feature of the world, a given, a thing to be adapted to. But now let's step back. Let's ask the question that would, in reality, be the loudest and most urgent question of all. How is any of this possible? Because in the universe as we understand it, as physics as we understand it describes it, stars do not move like this, cannot move like this. The distances involved are so incomprehensibly vast that even at speeds that would be physically catastrophic, a star could not cross a meaningful portion of the sky in a single night. What we have been imagining is not just unusual. It is, by every law of nature currently known, flatly impossible. And that impossibility is where science begins. Let's start with the practical. With the missions already underway, the spacecraft already out there, navigating the dark. Deep space missions might become significantly more difficult if the celestial reference frame changed every night instead of remaining stable. A reference frame in navigation is exactly what it sounds like. A framework of reference points against which you measure your position and movement. On Earth, landmarks serve this purpose. In space, the stars do. The precise, reliable positions of distant stars give spacecraft a coordinate system that is, for all practical purposes, fixed. The stars are so far away that even the motion of a spacecraft across the solar system produces only the tiniest apparent shift in their positions. They are effectively pinned in place, and against that fixed background, everything else can be measured. Remove that fixed background and deep space navigation becomes something closer to dead reckoning in a fog. You know how fast you were going and in what direction. You can calculate where you should be. But you cannot verify it against the sky because the sky is different today from yesterday, and your reference frame has dissolved. Missions to the outer planets, missions designed to fly precisely through a particular point in space at a particular time, missions where the margin for navigational error is measured in kilometers across a journey of billions of them, all of those would carry additional risk. Additional uncertainty. The kind that keeps mission controllers awake at night and drives the development of new technologies simply because the old ones are no longer sufficient. It would be a powerful and uncomfortable reminder that human exploration of space is, at its foundation, an act of navigation. And navigation requires something to navigate by. Breathe slowly. Let the room be quiet around you. There is no hurry at all. Now let's think about the moment of discovery. The morning after the first strange night. Not a world that has always had a shifting sky, but our world waking up to find that something has changed. If stars truly changed position every night, scientists would first question not the stars but themselves. Or rather, they would question the Earth. The first instinct would not be to say the stars have moved. The first instinct would be to say something is wrong with our instruments. That would be the most rational conclusion. A systematic error in the telescope tracking systems. A software glitch propagating through multiple observatories simultaneously. A problem with the reference catalog, the database of known star positions that every telescope uses to verify where it is pointed. You would check the instruments. You would check them again. You would call other observatories and ask if they were seeing the same thing. And when they confirmed that yes, the stars were in different positions, the next question would be, is Earth moving? Not moving in its orbit, not rotating, but experiencing some unknown cosmic effect. A sudden, unexpected change in Earth's own orientation in space. A gravitational disturbance from something massive and nearby. some interaction with an unknown field or force that was causing our own planet to shift its relationship to the cosmos around it. That hypothesis would seem more plausible initially than the alternative, because the alternative, that the stars themselves had moved, required something so far outside known physics that the mind would naturally resist going there until every other explanation had been exhausted. But eventually, the measurements would force the conclusion. The stars had moved, and then the scale of what had happened would begin to sink in. The immense distances between stars would make such rapid movement physically astonishing, since many stars would appear to have traveled across vast regions of the sky in just hours. Let's sit with the numbers for a moment, because the numbers here are genuinely staggering. The nearest star to our Sun, Proxima Centauri, is approximately 4 light-years away. That means light, traveling at 300,000 kilometers per second, takes 4 years to reach it. In human terms, at the speeds of our fastest spacecraft, a journey to Proxima Centauri would take tens of thousands of years. Now imagine that star appearing to move halfway across the sky in a single night, to cover that apparent distance in 12 hours. The actual physical distance involved, at that apparent speed, from that actual distance away would be incomprehensible. We are not talking about fast. We are talking about movement so rapid that it violates everything we know about how matter behaves, about how energy works, about what the universe is and how it operates. For a star to physically travel that far in that time, it would need to be moving at a speed that would, under every known physical law, be simply impossible. Not difficult, not unprecedented, impossible. The scientists looking at those measurements would know immediately that they were not looking at something at the edge of known physics. They were looking at something entirely outside it, a phenomenon for which no current theory provided even a starting point. That is a rare and extraordinary thing in science, and it would be terrifying and electrifying in equal measure. The discovery would force a reckoning with something fundamental. The discovery of moving stars would force scientists to reconsider one of astronomy's most basic assumptions, that the positions of distant stars change only very slowly, that on any human timescale the sky is effectively fixed. This assumption is not arbitrary. It is grounded in 2 centuries of precise observation. The tiny annual shifts in star positions caused by Earth's orbit around the Sun are measurable, but only barely, even with excellent instruments. The genuine proper motions of stars, their actual movement through the galaxy, are real but so small that they would not be noticeable to the naked eye over a human lifetime, or even 1,000 human lifetimes. The assumption of a fixed sky is one of the load-bearing walls of modern astronomy. Everything else is built against it. The coordinate systems, the distance measurements, the understanding of the large-scale structure of the galaxy, the entire framework of our knowledge of the universe beyond our solar system. Knock out that wall, and a very large amount of the structure built against it becomes uncertain. Not wrong necessarily, but suddenly in need of re-examination. Suddenly resting on a foundation that has shown itself capable of doing something nobody thought it could do. The discomfort of that moment in the scientific community would be profound and productive, because the most important scientific progress often comes not from confirming what is known, but from the violent disruption of what was assumed. Let yourself be still. Your body is heavy and warm. The thoughts can move slowly now like clouds. Researchers would not simply accept the observation and move on. They would search with everything available to them for an explanation. And in that search, they would likely discover entirely new laws of physics to explain how stars could relocate so quickly without visible catastrophic consequences. That phrase, without visible catastrophic consequences, is important. Because in the physics we know, moving a star at those speeds would not be a quiet event. It would release energy on a scale that would be detectable across the entire galaxy. It would produce shock waves, radiation, gravitational disturbances that would be obvious and unmistakable. The night sky in our world, if a star were actually moving that fast, would not just show the star in a new position. It would show the entire neighborhood of space around that star lit up with the energy of the movement. But in our imagined scenario, none of that happens. The stars move and the sky is otherwise normal. No catastrophic energy release. No visible shockwave. No gravitational disturbance. Just the stars quietly in different places. Which means that whatever is happening is not stars physically traveling through space in the conventional sense. It is something else. Something that achieves the same apparent result, the stars appearing in new positions, through a mechanism that bypasses the normal energy costs of physical movement. That is the clue. That is where the new physics would begin. Einstein's theories of gravity and spacetime might require major revisions if stars could relocate across the sky overnight without enormous energy costs. Einstein's general relativity is the best description of gravity we have. It tells us that massive objects curve the fabric of spacetime, and that this curvature is what we experience as gravitational attraction. It has been tested with extraordinary precision in hundreds of different contexts and has never been found wanting. But general relativity, as currently formulated, provides no mechanism for the kind of movement being observed. No way to get a star from one side of the sky to the other overnight without paying the full energy price of physically moving it through the space between. The scientists working on the problem would not throw Einstein out. You don't discard a theory that has passed every test ever applied to it. But you do look for extensions, for additions, for the places where the theory might be incomplete, where something has been left out that, once included, could explain what is being observed. That process of extension and revision is how science actually progresses. Newton's mechanics were not wrong. They were incomplete. Einstein extended them into regimes Newton couldn't have imagined. Whoever extended Einstein to account for moving stars would be doing the same thing. Building on a foundation rather than demolishing it. Finding the deeper theory that contains the previous one as a special case. The mathematics of that work would be some of the most challenging ever attempted. And somewhere, in a small office or a university common room or a cramped apartment with papers covering every surface, someone would be getting close to it. Physicists would search for previously unknown dimensions or cosmic mechanisms that allow stars to shift position in ways currently thought impossible. Extra dimensions are not new to physics. String theory and its relatives have long proposed that the universe contains more dimensions than the 4 we experience. 3 of space and 1 of time. Those extra dimensions are theorized to be compactified, curled up so small that they are undetectable at any scale we can currently probe. But what if they weren't entirely invisible? What if, under certain conditions, or perhaps always, in ways we had simply never noticed because we had never had reason to look, matter could interact with those extra dimensions in a way that effectively changed its apparent position in our 4-dimensional space? That is the kind of theoretical territory the physicists would be exploring. Not as science fiction, but as serious mathematics. Because the observation would demand an explanation, and the explanation would have to be found somewhere outside the current map of known physics. And somewhere in that territory, almost certainly, the explanation would involve space itself. Some researchers might propose that space itself is moving and stretching around the stars, rather than the stars traveling through space. This idea has a precedent in our own cosmology. The expansion of the universe is not the galaxies moving through space. It is space itself expanding, carrying the galaxies with it. The distinction is subtle but physically important. Things moving through space are constrained by the speed of light, but space itself is not subject to that constraint. Regions of space can recede from each other faster than light, because it is the space between them that is growing, not anything moving through it. Apply a version of that principle locally on a scale far smaller than cosmic expansion, and you have a potential mechanism. Not the stars moving through space, but local regions of space rearrange themselves, the topology of space changing in some way that places the stars at different apparent positions without requiring them to travel through the intervening distance. That would explain the absence of catastrophic energy release. The stars would not have been moving in the conventional sense. They would have been, in effect, stationary within their local regions of space, while space itself had folded and rearranged. Whether that explanation were correct or not, it would open doors, would generate new questions, new experiments, new ways of probing the structure of space at scales and in modes that no one had previously thought to investigate. The mystery would be the engine of a new science. The phenomenon could become one of the greatest scientific mysteries in human history, inspiring generations of investigation. There have been a handful of moments in the history of science when a single observation or experiment upended an entire worldview and set in motion decades or centuries of consequence. The discovery that Earth was not the center of the solar system. The finding that light travels at a constant speed regardless of the motion of the observer. The measurement of the cosmic microwave background, the faint afterglow of the Big Bang, confirms that the universe had a beginning. Each of those moments was not just a scientific event, but a cultural one. A recalibration of the human understanding of what the universe is and how it works. An invitation to a kind of thinking that had not existed before. Moving stars would be that kind of moment. Larger, perhaps, than any of those others. Because each of those previous revolutions had been about the arrangement or history of the universe. The moving stars would be about the laws themselves, about whether the physical rules that govern everything were what we thought they were, or whether we were living in a universe that operated by principles we had not yet imagined. Every generation of scientists for centuries afterward would return to it, would work on some aspect of the problem, would publish papers arguing for one mechanism or another, testing predictions against observations, building and demolishing theoretical frameworks. The mystery would not necessarily be solved quickly. The best mysteries never are. But working on it, the sustained collective effort of thousands of minds across hundreds of years, would produce knowledge that extended far beyond the original question. Would illuminate the structure of space, the nature of dimensions, the relationship between matter and geometry, in ways that transformed physics and mathematics and perhaps philosophy too. The moving stars would be a gift to science. An impossibly hard, impossibly rich gift. The kind that takes generations to fully unwrap. And finally, the thought that holds all of this together. The changing heavens could become a powerful reminder that the universe is far more dynamic and unpredictable than humans once believed. We have a tendency, in science as in ordinary life, to mistake familiarity for understanding. We have looked at the night sky for so long that we feel we know it. We have mapped it, cataloged it, measured the distances to its stars with extraordinary precision. And all of that knowledge is real. It represents genuine human achievement of a very high order. But the universe is not obliged to stay within the boundaries of what we have so far managed to understand. It does not owe us predictability. It does not guarantee that the phenomena we have observed so far represent the full range of what is possible. Moving stars would be the universe's reminder of that. A demonstration, conducted nightly in the most visible theater imaginable, that the cosmos is capable of things we have not accounted for. That our models, however good, are maps and not the territory. That beyond the edge of what we know, there is not simply more of the same, but potentially things so different that we would struggle, at first, to even formulate the right questions about them. That is a humbling thing, and also an energizing one, because a universe that can still surprise us completely, that can still show us something we have no framework for, is a universe with a great deal left to offer. A universe that has not yet finished being remarkable, that has more secrets than we have questions. And on a night like tonight, lying in the dark, with the sky above you doing its familiar, steady, ancient thing, there is something quietly wonderful in knowing that even the sky you have looked at all your life, is not fully understood. That somewhere beyond the edge of everything we know, the universe is still full of things we have not imagined yet. The night is deep. The stars are where they have always been. And that, for now, is enough. The mystery has been named. The impossible has been observed, recorded, confirmed. The stars are moving, and no existing framework of physics can explain it. And now the work begins in earnest. Not the work of wonder, though wonder is still present. Not the work of adaptation, though adaptation continues. But the specific, painstaking, collaborative, occasionally maddening work of science. The work of people who have decided that the universe has shown them something extraordinary, and who are not willing to stop until they understand what it is. This is a different kind of story, quieter in some ways, less visible than festivals and art and the great communal gatherings under spectacular skies. But in its own way just as human, just as driven by the same deep impulse that has always sent people toward the hardest questions rather than away from them. The impulse that says, I don't understand this yet, and I need to. The first question, before any theorizing can begin in earnest, is a question of perspective. When you see something strange in the sky, the first thing a careful scientist asks is not what is happening out there, but where is the effect originating? Is what I am seeing a real phenomenon in the universe, or is it an artifact of my particular vantage point? Is the sky changing? Or is the place I am standing from which I observe the sky changing in some way I haven't accounted for? Observations from other planets and spacecraft would be compared with Earth's observations to determine precisely this. Whether the movements were universal, happening everywhere in the solar system simultaneously, or only apparent from our specific vantage point here on Earth. This comparison would be both scientifically essential and logistically extraordinary. The spacecraft already operating in the outer solar system, orbiters around Mars and Jupiter and Saturn, probes moving through deep space, all of them equipped with star trackers and cameras pointed at the sky, would suddenly become the most important scientific instruments in human history. Not because they were designed for this purpose, but because they happened to be in the right place at the right time. The data would take time to arrive. Radio signals from the outer solar system travel at the speed of light, and even light takes hours to cross those distances. But when the data arrived and was compared with Earth's observations, it would answer the most fundamental question of all. If every observer in the solar system saw the same nightly changes, it would confirm that the phenomenon was affecting the stars themselves rather than Earth's viewpoint. Think about what that confirmation would mean, not just scientifically but psychologically. There is a kind of comfort, however cold, in the possibility that something strange is happening to us rather than to the universe. If Earth were somehow moving, somehow experiencing an unknown effect that altered our perception of the stars, that would be strange and frightening and deeply puzzling. But it would still be a phenomenon on a human scale. Something happening here to this planet, potentially with a local explanation. But if the spacecraft around Jupiter saw the same changed sky, if the probe passing beyond Pluto looked back and saw the stars in their new positions, if every point of observation across the entire solar system reported the same rearrangement, then there would be no local explanation available. The phenomenon would be in the stars themselves, out there, universal. And the universe, it would turn out, was doing something nobody had known it could do. That confirmation would land with a particular weight. The kind that changes how a civilization understands its place in the cosmos. Not a crisis of meaning, not exactly, but a recalibration. A quiet collective acknowledgement that the universe we thought we were living in was not the whole story. That there was more to it. More and stranger than we had known. The data from that comparison would be published simultaneously in every major scientific journal, would be discussed by everyone, would be the kind of news that stops traffic and fills public squares and makes people turn to the nearest person and say, "Did you hear? Settle a little deeper. Let your breathing be easy and slow. The night is long and quiet, and there is no need to rush through any of it." In the wake of that confirmation, the scientific world would reorganize itself around the problem. Universities around the world might establish dedicated institutes focused entirely on understanding the nightly migration of the stars. Not astronomy departments with a new research priority. Entirely new institutions, built from the ground up, designed specifically for this problem, with the kind of single-minded focus that only comes when a civilization decides that a question is important enough to throw its full resources at. These institutes would draw on every relevant discipline. Astronomers, obviously, but also physicists, mathematicians, cosmologists, and people from fields not normally associated with the night sky at all. Topologists, whose mathematics describes the properties of spaces and surfaces, might find their work suddenly central. Computer scientists capable of handling datasets of a scale previously unimagined. Engineers able to build instruments designed not to track known stars but to continuously survey an entirely unknown and constantly changing sky. And there would be philosophers, working alongside the scientists, not as decoration but as genuine contributors. Because the questions raised by moving stars were not only empirical. They were conceptual, about what space is, about what it means for something to be in a place, about whether the laws of physics are themselves stable or whether they too might be subject to some deeper variability that the moving stars were hinting at. Those institutes would be strange and exciting places, interdisciplinary in a way that most academic institutions never quite manage to be, because the problem would demand it, would attract the most restless and ambitious minds of each generation, would be places where the conventional boundaries between fields dissolved because the phenomenon they were studying dissolved them. The institutes would also inevitably be places of fierce disagreement, because the data would be compatible with multiple interpretations, and the people working on each interpretation would be brilliant and motivated and not inclined to give ground easily. Good science is always partly an argument, and this would be very good science. New branches of science might emerge to study the causes, patterns, and long-term consequences of nightly star migrations. This is how science grows. Not always through the gradual extension of existing knowledge, but sometimes through the sudden opening of entirely new territory that requires new names, new concepts, new methodologies before it can even be properly described. The study of stellar migration, whatever it came to be called, would be one of those new territories. Not astronomy as currently practiced, not physics as currently formulated. Something at the intersection of those fields and beyond them both, working on questions that neither discipline had previously had occasion to ask. What triggers a migration? Is every star equally susceptible to whatever the mechanism is? Or do certain types of stars, certain masses or ages or compositions show different patterns? Is there a relationship between the distance of a star and the apparent magnitude of its nightly shift? Do binary star systems, two stars orbiting each other, migrate together or independently? What happens to the gravitational relationships between stars when they move? Does the pull between them persist across their new positions? Or does that too rearrange itself nightly? Each of those questions would generate a subfield, would produce its own journals and its own conferences and its own vocabulary and its own community of people who had devoted their careers to that specific corner of the larger mystery. Science, encountering something it doesn't understand, does not stand still in the face of it. It subdivides, it specializes. It sends people down every available path simultaneously, trusting that enough paths taken by enough careful thinkers will eventually converge on the truth. But science is also, at its best, collaborative, and the collaboration required by this problem would be unlike anything previously organized. Observatories around the world would cooperate continuously, sharing nightly data to keep track of the shifting celestial landscape. Cooperate continuously is worth pausing on. Scientific collaboration already happens. Researchers share data, publish findings, attend conferences, correspond across borders and disciplines. But much of that collaboration is asynchronous. A paper published here, read there, responded to months later. A dataset shared after it has been cleaned and verified and accompanied by a full description of how it was collected. The moving sky would require something different, something closer to real-time coordination, because the sky would not wait for papers to be written and reviewed. Every night would produce new data, and that data would need to be combined with data from observatories on the other side of the planet, in different hemispheres at different latitudes, seeing different parts of the same changing sky. A global network of observatories, feeding data continuously into shared systems, reconciling their observations in near real time, building a composite picture of the whole sky as it looked each night. That network would be one of the great engineering and organizational achievements of that world. Not a spacecraft or a particle accelerator or a genome sequencer. Just data flowing between places, assembled into knowledge. The people who maintained that network, the data managers and calibration specialists, and the engineers who kept the pipes open between observatories in dozens of countries, would not be famous. They would not win prizes. But the science would not exist without them. And the data they produced would be vast beyond any previous scientific precedent. Massive databases would be required to catalog the changing positions of billions of visible stars over many years. Consider the scale. There are hundreds of billions of stars in the Milky Way alone, of which several thousand are visible to the naked eye and hundreds of millions are accessible to telescopes. If each of those stars is recorded at a new position each night, and that record is maintained with the precision required to be scientifically useful, the data generated in a single year would dwarf any scientific dataset previously assembled. Over decades, over centuries, the archive would grow into something that strains the imagination. Not just big data in the sense we currently use that phrase, though it would certainly be that, but a fundamentally new kind of record. A history of the sky's behavior, night by night, star by star, accumulating over time into a resource whose full value would take generations to appreciate. The infrastructure required to store and access that archive would itself be a major scientific and engineering challenge. Databases of that scale do not simply exist. They need to be designed, built, maintained, and continuously upgraded as the data grows and as the questions being asked of it become more sophisticated. And the people who designed those databases, who made the choices about what to store and how to structure it and how to make it accessible to researchers who did not yet know what they would need to look for, those people would be shaping science in ways they could not fully foresee. Every choice they made about structure and format and accessibility would constrain or enable the discoveries that came later. Database architecture as a form of scientific vision. It is less romantic than telescope building, but no less consequential. Rest now. Let your mind float. The words will come to you gently, and you don't need to hold on to any of them. Into that vast archive eventually would come a new kind of tool. Artificial intelligence systems might become essential for identifying recurring movement patterns hidden within the star's nightly migrations. The human eye and the human mind are extraordinary pattern recognition systems, but they have limits. They work well on data of a scale and complexity that falls within certain bounds. When the data grows beyond those bounds, when the patterns sought are subtle and the noise is enormous and the dataset spans decades and billions of data points, the human mind begins to struggle. Not through any failure of intelligence, but simply through the mismatch between the scale of the problem and the scale of what any individual person can hold in their attention. Machine learning systems do not have that limitation in the same way. They can process data at scales and speeds that are simply unavailable to unaided human cognition. They can search for patterns across dimensions that the human mind would not think to consider. They can hold the entire history of every visible star in their analysis simultaneously. The artificial intelligence systems built for this problem would be some of the most complex ever designed. Not general-purpose systems, but instruments. Tools built for a specific purpose, trained on the archive of nightly sky data, asked to find in that enormous record whatever structure might be hiding there. And they would find things. Not the explanation, not the final theory, but hints, anomalies, stars whose migration patterns seemed to cluster in ways that chance alone didn't fully explain. Nights whose sky arrangements showed faint statistical echoes of arrangements from decades earlier. Correlations between the migration patterns of stars in the same region of the galaxy, suggesting that whatever was driving the movement might operate on galactic scales rather than stellar ones. Each finding would generate new hypotheses, new targeted observations, new collaborations between the machine systems and the human scientists who knew how to turn a hint into a question and a question into a test. Science and technology would advance together, each making demands of the other, each pulling the other forward. Scientists would search for mathematical rules governing the movements, hoping to predict where stars would appear in the future. Prediction is the gold standard of science. Not just describing what has happened or explaining why it happened, but being able to say in advance what will happen next. A theory that can predict is a theory that can be tested. A theory that can be tested can be proven wrong. And a theory that survives attempts to prove it wrong earns a kind of confidence that no amount of post hoc explanation can provide. The search for mathematical rules governing stellar migration would be one of the great intellectual projects of that civilization. Not just because prediction would be useful, though it would be enormously useful to astronomers and navigators and engineers and everyone who depended on knowing where the stars would be, but because the rules themselves, if they existed, would tell you something profound about the mechanism. Rules imply structure. Structure implies cause. And cause is what everyone wanted to understand. The mathematicians working on this would be looking for patterns in the most complex dataset ever assembled, patterns subtle enough to have been hidden for years within the noise of apparently random movement. They would be doing something that sat at the boundary between mathematics and physical intuition, requiring both the formal precision of the former and the creative hypothesis-making of the latter. Most of them would fail. Most attempts to find the rules would end in dead ends, in patterns that held for a while and then broke down, in mathematical structures that were elegant but didn't match the observations. That is the normal condition of science at the frontier. Mostly failure, punctuated by the occasional breakthrough that makes the failures worthwhile. If the movements followed hidden cycles, researchers might eventually discover repeating patterns that occur over decades, centuries, or even millennia. A cycle is a kind of relief, scientifically speaking. It means the phenomenon is not purely random. It means there is something deterministic underneath the apparent chaos, some physical or mathematical structure that is producing the variations rather than pure chance. Finding that cycle, if it existed, would require patience on a timescale that individual scientists could not provide. A pattern that repeated every few centuries would need centuries of data before it became visible. The scientists who first collected the data that revealed the cycle would not live to see the pattern completed. They would be handing their work forward across generations, trusting that someone else would eventually have enough data to see what they had only glimpsed the beginning of. That kind of multi-generational science already exists in our world. There are datasets collected by astronomers centuries ago that are still actively used in modern research. There are monitoring programs begun in the mid-20th century whose most important results are only now becoming clear, because the phenomena they are tracking unfold on timescales longer than a career. In a world with a shifting sky, that long-term collective patience would be cultivated to an extraordinary degree. Institutions would be built specifically to maintain continuity across generations, to ensure that the data collected today was still accessible and usable 1,000 years from now, to pass forward not just the numbers but the context, the methodology, the understanding of what had been done and why and how it related to everything else. Science as inheritance, knowledge as a gift to descendants you will never meet. And to bring all of that data and those patterns and those mathematical rules into a single working model, the processing power required would be enormous. Vast supercomputers might be used to simulate the nightly rearrangement of the stars and generate forecasts for future celestial maps. Not just analyzing past data, simulating the phenomenon itself, building a computational model of whatever physical mechanism was producing the movements, running that model forward in time, and generating a prediction of what the sky would look like on future nights. The first such simulations would be crude, based on preliminary theories, limited by the processing power available, generating forecasts that were better than chance but not yet reliable. But each improvement in the underlying theory would improve the simulation. Each improvement in computing power would allow more stars, more time, more physical complexity to be incorporated into the model. And the test would come each night when the sky did whatever the sky did, and the simulation's prediction could be compared with the observation. Right or wrong, clearly and immediately. No waiting for a result. No ambiguity about whether the prediction had been confirmed. The sky itself would mark the homework. That nightly feedback loop, simulation predicts, sky delivers, comparison updates the theory, would accelerate the science in ways that no other test regime could match. Science usually has to wait for nature to produce the relevant conditions. Here, nature would produce new data every single night, and the theory would have to keep up. In that race between prediction and observation, between model and sky, between the human desire to understand and the universe's apparent indifference to being understood, the science would advance with a speed and an urgency unlike anything previously experienced. And perhaps 1 generation or 10 or 100 generations after the first strange night when the stars were not where they should have been, someone sitting at a screen in a quiet office somewhere would look at a simulation forecast and then look at the sky and realize that the two matched. Not approximately, not almost, precisely. And they would sit very still for a moment, in the way that people sit when something enormous has just happened. And then they would pick up the phone, and the world would change again. But that is a story for another night. Tonight, the mystery is still open. The data is still accumulating. The simulations are still running. The sky outside is still doing whatever the sky does, indifferent and ancient and full of things we do not yet understand. And there is something deeply comfortable in that, if you let it be. The universe does not require us to understand it in order to be beautiful. The night does not wait for a theory before it becomes the night. The stars are there. They are ancient and enormous and very far away. And for now, that is more than enough. There is a boundary we have been approaching for a while now. A threshold between the sky as something that affects us, that we observe and adapt to and wonder about and study, and something larger. Something that reaches beyond observation into consequence. We have been standing on the surface of the earth, looking up, watching the stars move and feeling the effects of that movement ripple through human life and human science. But the stars are not moving for our benefit or for our inconvenience. They are not performing for the telescopes or the festivals or the archive keepers. Whatever is happening at a scale that makes the entirety of human civilization a very small consideration indeed. And if the stars are truly moving, not just appearing to move from our particular vantage point but actually relocating in space, then the consequences do not stop at the edge of our atmosphere. They do not even stop at the edge of our solar system. They reach into the deep structure of the galaxy itself. Begin where the scientists would begin, with the models, Computer models of the galaxy would become much more complex in a world where stellar positions could no longer be treated as relatively stable over time. Galactic modeling in our world is already one of the most computationally demanding tasks in science. The Milky Way contains somewhere between 100 and 400 billion stars. Modeling the gravitational interactions between all of them, tracking their orbits through the galaxy, predicting how the large-scale structure of the galaxy evolves over time, requires supercomputers running for months to produce results that cover billions of years of simulated time. Those models depend critically on treating stellar positions as changing slowly and predictably. Each star follows an orbit through the galaxy that can be calculated from its current position and velocity. The model advances in time steps, updating each star's position based on the gravitational pull of all the others, and the result is a simulation of galactic evolution that matches what we observe with impressive accuracy. In a world with nightly stellar migration, every one of those model runs would need to be rebuilt from the ground up. The assumption of smooth orbital motion would be gone. Each star's position would need to be updated not according to calculated orbital mechanics, but according to whatever empirical rules, if any had been found, governed the nightly rearrangements. And if no reliable rules had yet been found, the model would need to incorporate that uncertainty explicitly, running thousands of variations, mapping not a single predicted future but a vast space of possible ones. The computational cost of that would be staggering. Not just more processing power, though it would require vastly more processing power, but a fundamentally different approach to the modeling problem. Less like calculating a trajectory and more like forecasting a weather system. Probabilistic rather than deterministic. A range of possible galactic futures rather than a single predicted one. And within each of those possible futures, the consequences would cascade. Let your body be heavy. Let the night settle around you. There is no urgency here, just the slow unwinding of a very large idea. Predicting future star locations would become one of astronomy's most important scientific challenges. Not just interesting, not just intellectually compelling, but practically urgent in ways that extended far beyond the purely academic. Because where a star is located affects everything around it. Its gravitational influence extends across enormous distances. Its light and radiation shape the environments of any planets orbiting nearby stars. Its movement through the galaxy stirs the material around it, compresses gas clouds, disrupts the delicate dynamical arrangements that planetary systems depend on for their long-term stability. A star that moves unpredictably is a source of unpredictable influence. And a galaxy full of stars that move unpredictably is, in principle, a galaxy in which the conditions for planetary stability, for the persistence of environments like Earth's, are fundamentally different from what they are in our own. The scientists working on prediction would be doing something that mattered beyond science. They would be trying to understand whether the universe that contained them was one in which life like theirs could persist. Whether the conditions that had allowed for billion years of relatively stable evolution on their world were likely to continue, or whether the moving stars would eventually bring something closer that would change everything. That is a different kind of scientific urgency from the usual. Not just the desire to understand, but the need to know whether the universe intended, in its vast and impersonal way, to let them continue. The changing sky could become one of the most closely monitored phenomena on Earth, attracting attention from both professionals and the vast global community of amateur observers. We touched on this earlier in the context of the sky as a shared experience, as a cultural event, as something people gathered to witness. But now the monitoring takes on an additional dimension. Because the sky is not only beautiful and mysterious, it is potentially consequential in ways that make careful watching feel less like a hobby and more like a responsibility. Professional observatories tracking stellar positions with millisecond precision. Amateur networks filling in the gaps, providing the wide field coverage that no single professional institution could maintain alone. Automated survey telescopes sweeping the sky continuously, feeding data into the global archive. Citizen science platforms allow anyone with a clear sky and a camera to contribute observations that might, added to millions of others, reveal a pattern that no one had noticed yet. The sky would be watched as nothing has ever been watched, with the collective attention of an entire civilization. Not just in wonder, though wonder would still be present, but with the focused, purposeful attention of a species that understood it was monitoring something that affected it directly. And in that watching, there would be a kind of intimacy with the cosmos that our own relationship with the sky, for all its richness, does not quite have. We look at our sky with curiosity and awe. In this world, they would look at theirs with all of that and also with the specific attentiveness of people who knew that what they were watching was not merely a spectacle but a condition of their existence. Now we move from the observers to the observed, from the watchers to what would actually be happening out there, in the space between the stars. If stars were actually changing their locations in space rather than only appearing to move from our perspective, many would occasionally pass much closer to one another than they do today. In our galaxy, stars are separated by enormous distances. The average distance between stars in the neighborhood of our sun is several light years. Those distances are so vast that stellar collisions are extraordinarily rare, occurring perhaps once in the lifetime of a galaxy. The night sky looks crowded with stars, but that is an illusion of perspective. In reality, the space between them is almost incomprehensibly empty. In a galaxy where stars migrated nightly, that comfortable separation would not be guaranteed. Stars that had spent billions of years at safe distances from one another could find themselves, on any given night, in unexpectedly close proximity. Not colliding, probably the random chance of two specific stars occupying the exact same point in space is still vanishingly small. But passing close enough that their gravitational fields interacted significantly. And gravitational interactions between stars, even at distances of fractions of a light year, have consequences. Close encounters between stars could alter the paths of their planets through powerful gravitational interactions. A planet orbits its star in a delicate balance. The star's gravity pulls it inward. The planet's orbital velocity carries it outward. Those two forces, perfectly matched, produce the stable elliptical orbit that persists for billions of years, that gives a world the time it needs for complex chemistry to develop, for life to emerge, for evolution to proceed through its slow and patient work. Introduce a second star passing relatively nearby, and that balance is disturbed. The passing star's gravity pulls on the planet too, and the effect depends on how close the encounter is, how massive the passing star is, and the geometry of the approach. In many cases, the disturbance would be small, a slight modification of the orbit's shape or inclination, something that might not even be noticeable in the short term. But planetary orbits, perturbed slightly, can drift over time. An orbit that is slightly more elliptical than it was carries the planet alternately closer to and farther from its star. The seasonal variations become more extreme. The climate becomes less stable. And a climate that becomes less stable is a climate that is less hospitable to life that depends on conditions remaining within certain bounds. Over many close encounters, over many generations of stellar migration, the accumulated gravitational nudges could push a planet's orbit into territory that its biosphere could not follow. Some planetary systems might be destabilized entirely when a passing star disturbs the orbits of planets, asteroids, and comets. Not just a small orbital modification, full destabilization. A close enough encounter with a massive enough star, at the right angle, could send planets careening into new orbits that intersect those of their neighbors. Could trigger a cascade of gravitational interactions within the planetary system itself, as planets that had coexisted stably for billions of years suddenly found their orbits crossing, found themselves encountering each other in ways that the original architecture of the system had never allowed. The history of our own solar system contains evidence of dramatic early instability. The nice model of solar system formation proposes that the giant planets, Jupiter, Saturn, Uranus, and Neptune, shifted significantly in their orbits during an early turbulent period, and that this shift drove massive bombardment of the inner planets and helped shape the solar system we have today. That early chaos settled. The system found a new stable configuration and has maintained it for billions of years. But the stability we enjoy is not guaranteed by any law of nature. It is a particular solution to a gravitational puzzle, one that could be undone by a sufficiently large external perturbation. A close stellar encounter would be exactly that perturbation. And in a galaxy where stars migrated nightly, such encounters would not be the extraordinary rarity they are in ours. They would happen. Not every night, not to every star, but with a frequency that, over geological timescales, would be significant. The galaxy in this world would be a less stable place for life. Not impossible, but harder, more precarious, requiring either extraordinary luck or extraordinary resilience. Let your breathing slow even further. Let the ideas wash over you without needing to hold any of them. In rare cases, wandering stars could capture planets from other star systems, creating worlds with entirely new suns. This is perhaps the strangest and most quietly beautiful consequence in all of this. A planet, orbiting its star for billions of years, suddenly finding that the geometry of its gravitational world has changed. Another star has come close enough, and the gravitational arithmetic has resolved in an unexpected direction, and the planet finds itself no longer bound to the star it formed around. It might drift for a while in interstellar space. A rogue world, dark and cold, no longer warmed by any sun, or the passing star might catch it, pull it into a new orbit around an entirely different sun. A world that began its life around one star ending up, through the blind mechanism of gravitational chance, orbiting a completely different one. What would that mean for anything living in such a world? If the transition were gradual enough, if the period of cooling and warming as the planet moved between stars happened slowly enough, perhaps some hardy life could survive. Perhaps the new sun would provide conditions not entirely unlike the old one. Perhaps life, if it existed on that world, would simply continue under a new sky, around a new star, unaware that anything fundamental about its situation had changed. Or perhaps not. Perhaps the transition would be too abrupt, the cooling too severe, the radiation from the new star too different in character. But the image is extraordinary regardless. A world with a history, a world that carries within its geology the record of two different suns, two different skies, a planet that has, in the deepest sense, moved on. Comet clouds surrounding stars could be disrupted frequently, potentially sending vast numbers of icy objects toward nearby planets. Every star like our sun is thought to be surrounded by a vast, diffuse cloud of icy objects, stretching far beyond the outermost planets, in the case of our solar system extending perhaps a quarter of the way to the nearest star. This is the Oort cloud, a reservoir of primordial material left over from the formation of the solar system, drifting in the dark at enormous distances, perturbed occasionally by passing stars or galactic tidal forces into orbits that bring them into the inner solar system as comets. In a galaxy with frequent close stellar encounters, those comet clouds would be stirred constantly. Each passing star would scatter the icy objects in its neighbor's Oort cloud, sending swarms of them falling inward toward the inner planets. Not the occasional comet, not the rare visitor that we see in our sky every few years or decades. A continuous rain, a persistent bombardment of icy objects arriving from the outer reaches of the solar system. Some of those impacts would bring water and organic molecules, the ingredients of life, delivered from the outer darkness. Some would bring devastation, the kind of impact that reshapes a world, the kind that, in Earth's history, punctuated the story of life with sudden dramatic change. In a world of frequent comet storms, life would need to be more resilient. It would need to be rebuilt more often. Or perhaps, in some counterintuitive way, life in that world would be more varied, more experimental, reset more frequently to try new configurations, shaped by a more interrupted and more dynamic evolutionary history. Now pull back, further back than planets and comets and individual stellar encounters, all the way back until the whole galaxy is visible. The Milky Way's spiral structure might become impossible to maintain if its stars were constantly relocating on short timescales. The spiral arms of a galaxy are one of the most recognizable structures in the universe. Magnificent, sweeping, luminous. In photographs, they look permanent, solid, like the arms of a pinwheel frozen in place. But they are not frozen. They are density waves, regions where the material of the galaxy is temporarily compressed, where the gas and dust and stars pile up as they move through the wave, like cars slowing down at a bottleneck on a highway. The wave itself moves at a different speed from the individual stars. Stars pass through it, pile up briefly, then continue on. That structure is maintained by the consistent orbital dynamics of billions of stars, each following a path that is predictable enough over the relevant timescales for the density wave to persist. Disrupt those orbital paths. Send the stars migrating nightly to new positions. And the carefully maintained architecture of the spiral arms would begin to dissolve. Not overnight, not even over centuries, but over the timescales that galaxies operate on, the coherent structure would blur and fragment. The elegant spiral would lose its definition. The galaxy would become something less structured, more diffuse, the stars distributed more randomly across its disk rather than concentrated into the sweeping arms. It would still be a galaxy, still billions of stars, still held together by their collective gravity. But the shape of it would change. The thing that makes spiral galaxies so visually extraordinary, that grand sweeping architecture, would slowly and irreversibly dissolve into something less dramatic but no less vast. And within that dissolving structure, strange new neighborhoods would form. Regions of the galaxy that are normally sparsely populated with stars could suddenly become crowded with brilliant starlight. In our galaxy, there are quiet regions and busy ones. The space between the spiral arms is relatively sparse, fewer stars per cubic light year, dimmer skies for any planets that happen to orbit there. The spiral arms themselves are more densely populated, brighter, more active with star formation and stellar evolution. In a galaxy of migrating stars, that quiet and crowded geography would be constantly redrawn. A region of space that had been sparse for billions of years might suddenly, over the course of a few decades or centuries of stellar migration, become densely populated. Stars arriving from other parts of the galaxy, clustering by the same random processes that sometimes cluster them in the nightly sky, but on a galactic scale. For any planets in that suddenly crowded region, the change would be profound. A sky that had been quiet and dark, with distant neighbors widely spaced, would transform into something blazing. Multiple bright stars visible from the surface, some close enough to cast shadows at night. The radiation environment of the system changed as new stellar neighbors altered the flux of particles and energy moving through the local space. Some of those changes would be hospitable, some would not. The universe, rearranging its furniture on a galactic scale, would not be consulting the preferences of anything living in the rooms being rearranged. And so we arrive at the full scope of what moving stars would mean. Not just a beautiful sky, not just disrupted navigation and recalibrated telescopes and extraordinary science, but a galaxy that was genuinely, fundamentally different from the one we inhabit. A galaxy in which stability, the deep geological and astronomical stability that allowed life for billion years to do its slow and patient work on this world, would be a rarer and more fragile condition, in which the long, uninterrupted stretches of time that complex life requires would be harder to come by, in which the architecture of the cosmos itself would be less settled, less reliable, less like a home and more like a landscape in constant motion. We live, it turns out, in a remarkably stable corner of a remarkably stable galaxy. The sky above us is fixed because the universe we inhabit is, at the scales that matter most for life, a quiet place. The stars hold their positions. The spiral arms persist. The solar system runs like clockwork because nothing has come close enough, for long enough to disturb it. That stability is not nothing. It is not guaranteed. It is not written into the laws of physics as a necessary feature of the universe. It is, in some profound sense, a gift. And on a night like tonight, when the sky is dark and the world is still and everything is, for this moment, exactly where it should be, there is something worth feeling in that. Quietly, without making too much of it. The stars are where they were last night. They will be there tomorrow. And that, in a universe that could have been otherwise, is a kind of grace. We have come a long way together. We began on the first strange night, standing in a garden or a field or a city street, looking up at a sky that had rearranged itself and not quite being able to believe what we were seeing. We followed that strangeness through history and myth, through culture and adaptation, through the disruption of navigation and the transformation of art, through the scrambling of satellites and the confusion of migrating birds, through the great scientific institutions that would rise to meet the mystery, through the galactic consequences that would ripple outward far beyond anything human beings could directly observe. We have spent a long time in this imagined world. And now, at the end of it, I want to slow down even further. I want to let the night be quiet for a while and just sit with what this world would feel like from the inside. Not the science of it, not the history or the consequences. Just the lived experience. The texture of an ordinary human life in a universe that kept changing the sky. Because in the end, that is where everything comes back to. The individual person, the upturned face, the simple, ancient act of looking up. Over long periods of time, astronomers in this world might discover that the galaxy itself looked different every generation. Familiar stellar neighborhoods constantly rearranging themselves. The patterns of the sky that your grandparents knew, documented in their archive entries and their paintings and their memories, bearing only partial resemblance to the sky you knew. And the sky your grandchildren would know being different again, in ways you could not yet predict. In our world, the night sky is one of the very few things that connects us, unchanged, to every human being who has ever lived. The stars that you can see tonight are the stars that Galileo saw, that Shakespeare saw, that the builders of Stonehenge saw. There is an unbroken thread of shared experience running through all of human history, and the night sky is one of the places where that thread is most clearly visible. In a world of migrating stars, that thread would not exist in the same way. Each generation would inherit a sky that was related to but not identical with the sky of the generation before. The archive would allow you to reconstruct earlier skies, to visit them virtually, to understand intellectually what your ancestors had seen. But you could not step outside and see the same sky they saw. You could not look up and feel that specific continuity, that quiet sense of standing in a line of watchers stretching back 10,000 years, all of them looking at the same lights. Instead, you would feel something else, something more solitary and more intimate. The knowledge that the sky above you, tonight, was yours, belonged to this moment, had been waiting for no one before you and would not wait for anyone after. Each generation in that world would stand alone beneath its own sky. And there is a particular kind of dignity in that, a particular kind of responsibility, to really look, to really receive what the night is offering, because nobody else will get this exact sky, and when you are gone, this arrangement of light will be gone with you. The concept of a permanent celestial identity could disappear in that world. Stars would be known not by their positions, not by the coordinates that fix them to a point in the sky and have fixed them there for all of recorded history, but by something more intrinsic. By their behavior, their movement patterns, the signature of their light, their chemistry, the particular fingerprint of their spectrum. A star's identity would be something it carried with it. Something that persisted through all its migrations, through all the rearrangements of the sky, through all the nights it appeared somewhere new. Like a person whose identity is not their address but their character. Not where they are but what they are. There is something worth sitting within that idea. The way we identify the things we love most is not usually by their location. We know people by the sound of their voice, by the particular way they laugh, by the things they care about and the way they move through the world. Location is incidental. The person is something else. A sky that required you to know stars by their character rather than their coordinates would be a sky that demanded a deeper kind of attention. Not just where is that, but what is that? What is it made of? How does it behave? What is the quality of its light? That would be a more intimate relationship with the stars. More like knowing them than knowing where they are. And perhaps there is something in that worth carrying back into our own relationship with the sky. Not just finding the familiar shapes and naming them and moving on, but staying. Looking at the quality of a particular star's light. Noticing the color of it, the steadiness or the slight twinkling, the way it sits in relation to its neighbors on this particular night. Knowing it a little more than you did before. Your body is very heavy now. Your thoughts are soft and slow. Let the words carry you. Despite all the scientific advances that centuries of study would bring, each sunset in that world would still carry a particular quality of feeling. A low hum of anticipation in the chest. The particular alertness that comes just before something unknown reveals itself. Because nobody would know exactly what the sky would look like next. The forecasters would have their probabilities. The models would have their predictions. The archive would have its patterns and its cycles and its hints of structure within the apparent randomness. But until the sky actually darkened and the stars appeared in their new configuration, nobody would know. Not really. Not with the certainty that makes surprise impossible. And that irreducible uncertainty would keep the wonder alive. Through all the centuries of study, through all the generations of scientists and artists and sky watchers and archive keepers, the moment of revelation would remain genuinely revelatory. Every clear evening, in every part of the world, there would be people pausing in what they were doing and turning their faces upward as the first stars appeared. Not because they had to, not because it was useful, but because they could not quite help it. Because the sky was about to show them something they had never seen before, and there is something in human beings that will always turn toward that. Even after centuries of study, people might still gather each night to witness the stars' movements firsthand. Not just the scientists, not just the dedicated observers, ordinary people, families on rooftops, friends in parks, couples lying on their backs in summer grass, old people sitting quietly in gardens, having watched 1,000 different skies over a long lifetime and still finding that the 1,001st held something worth seeing. The combination of scientific curiosity and simple wonder would persist, would not be diminished by understanding, or by familiarity, or by the sheer repetition of nights, because the sky would not be repetitive, would not allow you to become fully accustomed to it. Every night a new reason to look. Every night a reminder that the universe was larger than anything you had made of it in your mind. In our world, there is sometimes a sadness in the relationship between science and wonder. The feeling that understanding something takes away its magic. That once you know what a star is, once you have the physics and the chemistry and the distances, something ineffable is lost. But the greatest scientists have always known that this is not true. That understanding deepens wonder rather than dissolving it. That knowing what a star is made of makes it more extraordinary, not less. That the universe, seen clearly, is more astonishing than any version of it that ignorance could invent. In a world with a shifting sky, that truth would be lived daily. The science would be rich and deep and constantly advancing. And the wonder would be completely undimmed, because science would never quite catch up with the sky. The sky would always be slightly ahead, always offering something the models hadn't predicted, always finding a new way to be astonishing. The changing stars could encourage people to spend more time looking upward. Not just the dedicated watchers, not just the ones who made it their profession or their passion, but ordinary people going about ordinary lives who had simply grown up in a world where the sky was interesting every night. And a population that spent more time looking upward would be a population with a slightly different relationship to the scale of things. A slightly different sense of where they fit in the universe. A slightly more regular reminder that the world they inhabited extended far beyond the edges of their daily concerns, far beyond the boundaries of whatever was worrying them or preoccupying them or making the present moment feel more total and absolute than it actually was. There is a well-documented effect in our world. Looking at something vast, something that exceeds the usual scale of human experience, produces a particular feeling. Not quite humility, not quite awe, something that sits between them and contains elements of both. A reduction in the intensity of self-focus. A brief, gentle loosening of the grip of the immediate. A world that looked up more would be a world that experienced that loosening more regularly. That was reminded more often of its own smallness. Not in a dispiriting way, but in the way that seeing a mountain range from a distance puts your own hills in perspective without making them less real or less lovely. A world in closer connection with the universe. A world that wore its cosmic context more lightly and more consciously than we sometimes manage to wear ours. Philosophers might use the ever-changing stars as a symbol of impermanence, arguing that even the heavens were in constant motion. That nothing in the universe, not even the most ancient and distant lights in the sky, was immune to change. In our philosophical tradition, the heavens have often served as a symbol of the permanent, the eternal, the unchanging backdrop against which the brief drama of human life plays out. The stars were there before we arrived and will be there long after we are gone, and that persistence seemed to say something about the nature of things, about the existence of something beyond the flux of ordinary experience. In a world where even the stars moved, that symbol would shift, would carry a different meaning. The heavens would not be the realm of the permanent, but the realm of the persistently impermanent. Change going all the way up, all the way out. No level of the universe is exempt from it. No height at which things finally settled into stillness. And perhaps that would be its own kind of comfort. A universe in which change was not a deviation from the natural order, but the natural order itself. In which impermanence was not a failure of permanence, but simply what everything was made of. In which the fact that things change, that moments pass, that nothing holds its form forever, was not a tragedy but the fundamental character of reality, shared equally by the smallest human life and the most ancient star. There is a certain peace available in that idea, if you let yourself settle into it. The peace of not struggling against the nature of things. Of understanding that the passing of everything, including the most beautiful things, is not the universe getting something wrong. It is the universe being exactly what it is. The idea of destiny being written in the stars could evolve, in that world, into something different from what it means in ours. In our tradition, that phrase carries the sense of fixedness, of fate determined in advance, inscribed in a permanent celestial text that cannot be altered. The stars as a record of what will be, unchanging and authoritative. In a world of moving stars, that idea would have to become something more fluid. If the stars were always changing, if the sky that was there on the night of your birth was different from the sky the night after, and the night after that, then the stars could not be read as a fixed inscription. They could not be a text that said this is how it will be. They could only be a text that said this is how it is right now, in this moment, and now it has changed. Destiny written in such stars would not be predetermined, would not be a fixed outcome waiting to be discovered. It would be a constant rewriting, a future that was always in motion, always being revised, always offering new possibilities as the sky rearranged itself and the cosmic context shifted. And perhaps that is a more honest metaphor for how the future actually works. Not a fixed destination we are moving toward, but an open space that is always being shaped by what has happened and is always capable of becoming something we did not expect. A sky that changed every night would say to anyone who looked up at it, "The future is not written. It is being written, right now, tonight, and it will look different by morning. We are nearly at the end now. Let your body be completely still. Let your breathing be deep and slow and regular." The night sky would become, in that world, one of humanity's most shared experiences. People everywhere, every evening, comparing notes. What did you see? Was it visible from where you were? Did anyone else catch that extraordinary gathering just before midnight, low in the eastern sky? That conversation, conducted across every language and every culture and every corner of the planet, would be one of the great connective tissues of human civilization. A common reference, a shared text that was rewritten every night and read by everyone. A reminder delivered nightly that the sky was not owned by any nation or any tradition or any individual perspective. It belonged to everyone equally. It was looked at by everyone simultaneously. It was, in its restless and indifferent way, the most democratic thing in the world. And beneath that shared experience, something more intimate. Humanity's relationship with the cosmos might become more personal in that world. Because every night would offer something that no previous generation had seen. Your sky, this moment's sky, the particular gift of this evening, given to the people alive to receive it and to no one else. Every person who looked up on any given night would be seeing something for the first time. Not the first time they had seen it, the first time anyone had seen it, the first time it had ever existed. And they would know that, would carry that knowledge as they looked, a quiet awareness that the beauty above them was entirely new and entirely temporary and entirely, in this moment, theirs. That is a different relationship with the cosmos from the one we have. Ours is the relationship with something ancient and permanent and impersonal, vast beyond imagination, but also stable, fixed, the same for everyone across all of time. Theirs would be the relationship with something that showed up every night, that offered each generation something it had not offered any generation before, that was, in its strange and inexplicable way, responsive to the present. Not aware of it, not intentional, but knew within it in a way that felt, if you were standing there watching, almost like attention. In the end, a universe where the stars moved every night would transform the night sky from a mostly fixed backdrop into a living, ever-changing cosmic spectacle. That is the simplest way to say it. A living sky, not living in the biological sense, not conscious or purposeful or aware, but alive in the way that a river is alive, in constant motion, never the same twice, shaped by forces larger than itself, producing in its movement something that feels, from where we stand, like vitality. Our sky is not like that. Our sky is quiet and fixed and ancient, and it will look tomorrow almost exactly as it looks tonight, and that sameness is itself a kind of beauty. The beauty of the reliable. The beauty of the thing that was there when you were young and will be there when you are old and connects you, across all the changes of a life, to something that does not change. But the other beauty is also real. The beauty of the unrepeatable, of the thing that exists fully only in this moment and then becomes the past, of the impermanent made magnificent. And perhaps the deepest truth of this long journey we have taken together, through the moving sky and all its consequences, is simply this. Wonder is not fragile. It does not require a fixed sky or a shifting one. It does not require perfect conditions or perfect knowledge or perfect certainty about what you are looking at. It requires only attention, the willingness to look, the willingness to let what you see actually reach you, rather than sliding past the surface of your awareness. The willingness to be, for a few moments, fully present beneath whatever sky you happen to be under. Our sky, the one above you right now, is fixed. The stars are where they were last night, where they will be tomorrow night, where they were when the first human eyes turned upward to find them. That permanence is real, and it is beautiful, and it connects you to every person who has ever lived beneath it. And it is also, if you look carefully enough, endlessly new. The light reaching your eyes tonight left those stars years ago, decades ago, centuries ago, and has been traveling through the dark ever since, arriving at this exact moment at your exact location to be seen by you and no one else in quite this way. The sky that is above you right now has never been seen from exactly where you are, at exactly this moment by exactly these eyes. It is, in the only way that finally matters, yours. The universe is very large and very old and very strange. It is full of things we do not understand and things we have not imagined and things that, perhaps, we are not yet equipped to imagine. It will outlast everything we have built and everything we have thought and every question we have ever asked about it. And yet here you are, in it, under its sky, part of it, in the way that everything that exists is part of everything else, connected by gravity and light and the ancient matter that makes up everything from the stars to the ground beneath you to the body you are lying in right now. That is not nothing. That is, if anything, is everything. The sky is above you. The night is around you. And somewhere up there, through the dark and the distance and the deep and ancient silence of space, the stars are simply being what they are, as they always have been, as they will be long after tonight. Rest now.